And welcome everyone to the Keshe Plasma Reactor Group for Tuesday, December 6, 2016. Only 2 weeks of shopping days until Christmas, but who cares? And more importantly, it's only 15 days until the 21st of December, one of the most important days of the year. Why? Because the days start to get longer. And boy, they've been short and dark in this part of the world. So, let's get on with the show. And I'm wondering what others might have to show today. And I can show what I've been working on. Trying to get to work. I've had a bit of an issue with things, but I'll just briefly describe what I've been doing. I'm going to move the video camera over. Excuse me while we walk over here. And I've had the let me zero in on that a bit. I've had the trusty little 4x4, it's actually a two-wheel drive vehicle here, and we saw that last week and so on. I've been playing with that a bit, and I've now got an effective, where's my, there it is. I now have an effective SEPTA seal on the top, so I'm able to actually stick a hypodermic needle into my reactor, and I think I can even find my controls. I'll show you how that works. Pretty basic. I've got a SEPTA seal, which enables the needle to go through the SEPTA and still maintain a seal. And when it's rotating I say, oh, it's not very happy. I think I may have fried something last time around. Let's just see if this works. We'll jump start. There we go. That's all it needed was a jump start. Anyway, you can, whoops, I guess you can't see this. There's the needle. So yeah, the idea is I've got the remote control here, and I can control the speed of the rotating orb, and I've got the hypodermic in here, so I can rotate. You see the little bubbles there that I just shot in. I can also put some water in to take up the airspace that's in the top there, so there's no air, and so on. It gives me a lot of options to be able to inject the specific materials I want to into the center core while it's rotating, which is all pretty cool. But I ran into the problem of I wanted to maintain an air bubble in the center of this, and when it's rotating on the vertical axis to the gravity, it'll form that little tube in the middle that goes down into the core, but it won't form a bubble in the middle of the center of the sphere, a separate bubble. It'll only form that vortex tube going down. Unless, the only way you can do it is to move the whole apparatus sideways so the rotating axis is horizontal or near to horizontal instead of vertical. And I tried to do that with this funky little machine here, and its bearings and its axles are just, I don't know why, but it's just not up to the job of rotating this 2 kilograms, half a kilogram orb at high speeds on a sideways. It tolerates it the way it is here. Even that's getting really quite loose and things are starting to bounce around a bit. But horizontally it just won't do it. So I decided I'd start building another apparatus. And I actually got it running, but it wasn't working properly, and I had to abandon it and rebuild. So I'll just show you what I've got here now to attempt to replace this contraption. And bring this down a bit. Okay, what I have is a box. I'm going to retract this a bit. And, one of the lights is reflecting. Well, you kind of get the idea anyways. It's a box. You kind of see. I actually have it on the back end of my other apparatus here. You guys able to see this? I don't have the video spotlighted. So
yeah, it is perfectly clear.
Okay.
Yeah, it's completely clear.
Alright, good. So yeah, I've got it on the back end of my my other apparatus here, which is able to rotate. Whoops, I just lost a part. It's able to rotate back and forth and so on, which I've shown before, which is a nice feature. So what I did is I just mounted the other one onto the back end of the same board, and I'm able to do, let me back up a bit here, it'd be easier to see, I think. What I can do now is I can rotate this apparatus as well. I would if it was hooked up properly. So I can actually turn it the way I want to. And I just had it rigged up, but I had to take it all apart again to put on a different axle. But I can sort of show you briefly what it looks like. It did look like. There it is. Bear with me a second, I hadn't planned on the problems here. Okay, basically that's it. And if I had a volunteer orb, you, come with me. Okay, so the idea is I've got this box, and I can open it up. I can take my orb of choice and slip it into the box here and screw it into my assembly, which has a bearing and shaft on it. It's a little funky, but it's sort of get the idea. And I've got my trusty little sewing machine motor powering this. I'm going to put a screw in here to hold it all together. And here's the screwdriver. So, boy, there's a lot of reflection there. I wish I could eliminate some of that. Let me try to take out the top light. Maybe that'll... Well, you get to see my computer screens more than anything else. It's a little
Just tip that front panel so it's reflecting a dark part of your room, right? Turn the unit about 15 degrees. That should take care of the reflection. Other way. Perfect, right there.
Okay, that can work. And okay, so I've got the Variac over here that I use this unit here to control the voltage, and let's just sort of whip it up and see if it I'm not sure if it's going to hold together here. It's all a little bit iffy, let's say. Yeah, it just got stalled out. It's hitting on one of the bolts a little bit. Maybe I can overcome it. Oh, it's way out of balance, way out of round rather, so I won't be able to go very fast with it. I have to set it up so that's the problem I was having before. That's why I have a new shaft for it, a new setup. But you kind of get the idea. We have a rotating sphere once again, which is cool. And the nice feature is that I'm actually able. I've got a smaller hypodermic here that I can actually put through a hole in the top of my box, and if this thing wasn't whipping around so much, I'm actually able to stick it into the Septaseal and access the center of the sphere while it's rotating. It's going to be a lot of fun. And so what I can do then is, once I have, there's a little bit of air in there now, for example, and if it was going faster, which I can't really do with all this vibration, it would start the little vortex in there that we've all seen before, I think. And then what I can do is I can turn it sideways, and then some really neat things start to happen, like you see what's happening there now. And that's actually way too many bubbles, and it's not quite what I wanted to demonstrate, but it gives the idea. I don't know if I can make it a little bit faster. Okay, so you get the idea that when it's sideways, you have a totally different bubble configuration than, like, even this much of an angle. You're back to the vortex and the bubble at the top. We take it a little bit sideways. Overcome this little screw here. And already some bubbles are starting to form toward the center and even down at this end. And you can start to control them. When there's less air in there, then I can actually have a little bubble, and I can control exactly where that bubble is, anywhere in the sphere, in the center of the sphere. And which is what I wanted to demonstrate, but it's
like a gyroscope.
I need a little more time and attention on there. But basically, the way you control the bubble is, or the bubbles in this case, is by the angle, number one. So it's not necessarily directly horizontal is the optimum, because horizontal might make the bubbles go more toward this end, for example, or you can control it by the angle, and it's very exact to maybe like half a degree or so. Like the difference between that and that makes a huge difference in where the bubble will be. So that's one factor. The other factor is the speed itself makes a difference too. You can control somewhat where the bubble is with the speed as well. So it gets really interesting at higher RPMs, which I wish I could accomplish here, but it's just not possible. But at higher RPMs, that little bubble in the middle starts pulsating, because the sphere is never completely true, and it's always vibrating in there a little bit. Especially you get up toward the resonant frequency of the sphere, then all the vibrations would be orientated toward the center of the sphere and its harmonic resonant frequency, and that'll cause the little bubble in the middle to start pulsating. And when that pulsation becomes strong enough, then we get a sonoluminescent effect, which is the light given off by the collapse, and you see how the bubbles continue there for quite a while. Especially if it's a small bubble, it gets entrained in the center vortex there for quite a while. Okay, so actually maybe I can take a bit of the air out. Let me see if I can do that while it's vertical. Probe the septa. Okay, my needle's in. And let's see if I can pull some of that air out. Actually, what I need to do is add water. That's the best way to do it, rather than subtract the air, because the air can come back in. So I've got some distilled water here. I'll just add some distilled water to it. This syringe only takes a milliliter at a time, so it's take a few shots probably to do this procedure. Okay, that filled it up a little bit. I have a bigger syringe for this procedure, I guess. Okay, another couple of shots, pretty much will have it. Shooting tiny little bubbles in there. Okay, let me see if I can remove some of the air. It's mostly coming out. Okay, there we have almost all of it out there now. Alright. So let's try it again. Actually, see if I can make a little adjustment on the wobble. Maybe I can take care of that. If anybody has any questions or comments in a couple of minutes here, then that might be a good idea. Going to have to be close enough without taking the apparatus apart, which I don't want to get into right now. Okay, there's a few bubbles at the top. They're like tiny little bubbles. Let's see if we can see anything else there that shows up. I think I've gotten rid of all the bubbles. Now we don't have any bubbles to play with. Well, it might form its own bubble anyway from rotating, because water normally has air in it, and the air will come out with the rotation. So let me rev it up and see what happens here now. to walk forward, Captain. I don't know if she can take any more.
I'm wondering if you put the syringe back in and leave it in, sunk right to the bottom of the septic seal, if that will stabilize the top.
Yeah, it does help a bit, yeah, it's true, but we have a more basic issue that needs to be dealt with. That whole bottom base is wobbling way more than I expected, basically. So I'm seeing if it can self-balance. Because I've had take it up a bit. It's not very happy. Okay, let's see if there's any air bubble in there. Oh, there's a bubble. Perfect. Yay. It's a little funky with the bouncing, but there it is. Whoa, horsey. Whoa. Okay, so there, you can kind of see the little bubble moving back and forth there.
Oh, yeah.
A little better lighting somehow. It's
No, that lighting was good, Rick. We could see it really easy.
okay. So I'm going to try to center it according to my angle from this direction, and so at this speed, I get, whoa, it's going too far. Back, come on. There, need about there. Okay, there, that's more or less centered there. It's a little hard to do without the RPMs being up higher, which stabilizes everything much better. But it's interesting, you can see the bubbles pulsating like crazy from the effect of the outer round sphere. So it's an interesting idea that that bubble is being pulsated by the pressures inside the sphere. So yeah, that more or less demonstrates what I want to show there, without everything falling apart on us and causing so much noise and confusion. But basic idea being that the now that I'm able to trap the bubble in the center and pulsate it at the resonant frequency of the sphere, well, that could be tricky because the resonant frequency may be, I'm thinking in the range of 10 or 11,000 RPM for this unit in order to get the correct frequency that would be a resonant frequency. So depending, there could be harmonics and so on involved. That's why it has to be a gradual process where you test, you know, each increment in RPM and watch what goes on and notate the bubble, see what happens to it when it starts pulsating and so on. And at a certain point, though, the forces, the fields and the pressures and essentially the conditions for that bubble in there might be such that it can attain a sonoluminescent effect, or at least a particular effect of extreme pressure and heat in that bubble. Because we know with implosion bubbles and with sonoluminescence and cavitation that when that bubble expands out and then suddenly contracts, it contracts at roughly 4 times the speed of sound. So it's got a Mach 4 force pushing inward on the little bubble from all sides, from a constant force. So that force is so extreme that the pressure and the temperature actually go to infinity on the in the theoretical end of things, and in practicality, they've measured temperatures of a sonoluminescent bubble that's collapsed and expanded like that to be in the 20,000 centigrade is what they've measured, but they predict that it can go up into the millions of degrees temperature while it's flashing in there, basically for a few picoseconds, and it's off, and it flashes again for a few picoseconds. We see it as a continuous glow. A white, bluish white light would come from the center of the globe, essentially, when sonoluminescence was happening. So my idea is to try to keep away from the transducers and the heavy-duty ultrasonic gear that they usually use to attain sonoluminescence, and try to work with some of the natural fields and the building up of fields that can occur in a sphere that's being rotated. So that's the idea, sort of the plan here. I would have liked to demonstrate it better today, but alas, my axle arrangement was not behaving properly. I've got a new I need some more lighting here in just a second for other things. Got this new part here. It's an arbor for you would normally attach it to a motor and be able to put a grinding wheel and that kind of thing on it. So in this case, it'll fit through my bearing here, and I'll be able to mount the globe on one end and the belt pulley on the other end. Turn it off. So, yeah, work in progress. By next week we should be able to get more results with it and more control and so on. Maybe by playing certain music to it, it will respond as well, I'm hoping. Alright, well, enough about that for now, probably. Any questions, or shall we move along here?
I just want to ask, if I may, hi, it's Libby. Why are we, and I am one of them, so fascinated by these bubbles? Because they're just like magical entities in those bubbles.
Yeah, well, that's a good question. I just realized I don't have my headphones on, so it's probably echoing in live stream and making a mess out of the audio, unfortunately. So let me put my headphones on.
Thank you for saying that, because when I say it, it's just like I would really want to just like talk about it. It's beautiful. It's amazing. That's what I think. Thank you.
Okay, so let's look at that for a few minutes here. It might be interesting to penetrate that topic. So, how do we define that exactly? What was the comment exactly that inspired that?
Why are we so fascinated with the bubbles? When I see the bubbles, there's magic there. There's some, like, it's an entity of some kind. And when I saw those bubbles, I really think, and if you look at my avatar, it's all about the droplets, the other part of life, the air. I don't know, but anyways, I just wanted to ask if others feel that way, but I see that we do.
Well, I mean, some people, when they see the foam from the waves breaking in the ocean and so on, that's or hear them as well, then that's you know, it's inspiring in many ways. And I mean, think about bubbles. How do we relate to bubbles as a child? First thing you do is have a bubble bath. You know, you're probably a day old and you have your first bubble bath, and you're there and there's like bubbles all over the place. Oh, what's this all about? This is cool. And maybe that reminds us, and when I just said that, it reminds me of what someone else said earlier about orbs and about you know, some people have orbs that appear in the space and so on when they get into these higher psychic or meditational spaces and so on. They see orbs, and some people are able to photograph them supposedly and so on. And maybe, I mean, Mr. Keshe has talked about that as well, and many other people, that some entities may exist in a you know, basically a spherical shape as an energy form, or as some sort of intelligent entity that's not of a human form. And maybe that's more like the reality of the situation. Maybe these orbs actually exist everywhere through the universe, and we can't normally see them. We're obscured from that vision, thankfully, probably, or most of us would go crazy. And instead we see things from the very, very narrow perspective as humans. When you look at the whole electromagnetic spectrum, the spectrum of light that we're able to see is only a narrow band of that. So in a way, we're missing out on all of that other information that could be going on simultaneously in other dimensional levels. So perhaps we're reminded of bubbles and orbs and the whole magical world that is attached to all of that, just through seeing, you know, something very simple like the bubbles in a sphere. Just seeing a sphere in itself. I mean,
well, a drop of water, a drop of anything, magical, right?
Yeah, a drop, or even that spherical shape. You know, that's what, you know, gypsies have used for millennia. You can tell the future, you can tell the past, you can, you know things just through looking into the sphere. And you know, spheres have been used for time immemorial. For various ones have been created out of, you know, you name it, every material probably. And in fact, there was something I read recently. It was about a sphere. It was an ancient writing from Babylonian times or something, and about the power of a sphere being very special and so on. So it's yeah, our fascination with bubbles, and it's part of a magical world that it's the same with me. When I first saw those bubbles in there, and when I first turned that apparatus sideways, and I saw, whoa, I can trap these bubbles now and move them sideways. And another thing I noticed was, if you have more than one bubble in there, say you have 2 or 3 bubbles and they're sort of bouncing around and interacting, then what happens is they maintain their individuality. You could run the reactor for half an hour and they'll bounce around in that same line. They'll bump into each other. They can even transfer places, but they won't combine. They won't combine to make one big bubble. They just bounce around in their own individuality. I thought, whoa, that's
Perfect.
really strange. So I think, Alfred, the microphone's open, but maybe you know it is. So
it's so beautiful. It's just to remind me of life. I mean, every drop of water contains life, and that's what, when we see that, and how they do stay separate from each other, it's just amazing. I can't really speak too hard. I got too many roommates, but anyways, I'm just so excited by the. Thank you.
Right on. Thank you, Libby. Yeah, and think about water, and it's, you know, we're finding out, we thought that there was, you know, no water on other planets and are special, and that's what makes us special, is the water here. And now they're just finding out that, whoa, it looks like there's big oceans on Pluto, of all places. Water oceans on Pluto. Who would have guessed? One of the moons of Jupiter has huge oceans in it, bigger than our oceans, like 4 times as deep, they say, and so on. And you think there isn't life in every single drop in those oceans? You bet there is. You bet there is. because like there's nowhere in any of our oceans that there is not a single drop that isn't completely full of life. Scientists just discovered a couple of weeks ago, big discovery, this new sort of plankton. It's above a virus and above a bacteria, but it's basically a single-celled creature that lives in the ocean that they didn't even know was there before, and it's pervasive everywhere in all oceans. And I just laugh. And they said, the scientists said, it's like discovering lions when before all you've seen is gazelles and zebras. It's amazing, and we have all these tools to our disposal and so on, and yet they're still making a major discovery, like that basically every drop of water has these little microbes in it that completely surprise the scientists. So yes, there's life everywhere, every drop of water, and you bet it's through the whole universe. There's no doubt about it.
Yeah, they say if you've got a hammer, everything looks like a nail.
Yes, right. I just discovered water on Mars recently as well. One big area that's, or was it the moon? Jeez, both they discovered water on. The size of Lake Superior, one area underneath the soil, but it's all moist basically, and it contains a huge amount of water. So, times are changing. I was told Mars was dry, not a drop of water. Believed that for nearly all my life. In fact, they poo-pooed Tesla when he said there was water on Mars and there's actually canals, and they said nope, it couldn't be. That's all just is too dry and could never happen. Anyway, hi Lee, I see you're patiently sitting by with some sort of goodness there.
Hello,
So,
Rick.
let's have a look at what you have to offer and get off my high horse here. Let me just get you set up.
Well, I went to the salvage store again up at the dump and found another weed whacker.
Oh, yeah.
This is the end on the weed whacker where the string comes out.
Mm-hmm.
And this one had a nice screw cap on it.
Mm-hmm.
So you could, if you wanted to, you could mount big balls glue them right onto the
It's
cap
got
there.
It's got kind of an indentation on the cap. Is that it? It's got a place.
Yeah, that's where the string goes for the.
Oh, right. Okay, that's handy to
But
center
it
it.
also had a hole in the center where I put my pipe fitting. So.
Oh, I see.
So I'm gonna screw that cap on, then screw my.
Oh, that's really nice. So
ball
the pipe fitting more or less fit right in there.
I had to enlarge the hole a little bit,
Okay.
and I went and got it off center, so this thing won't spin centered yet.
Oh, okay. Yeah, that's the trick. Eh? It's
And,
quite a deal to keep things on center.
And this
Yeah.
this one, I cut down the sides for this one, and I just got the center shaft, and that fitting. It's just a light bit of play there. So by the time I get some glue in there, and I can center it up pretty good, and be able to screw something in that one too.
Yeah.
The nice thing about these motors is they'll go up to about 10, 12,000 RPM.
Yeah.
And underneath here, you got a fan.
Mm-hmm.
So I'm just using the weed whacker plastic housing here. I just cut off the excess plastic.
Mm-hmm.
And, so the motor's clamped into that plastic housing.
Yeah.
And this fan sucks the air out the middle of the motor and blows out here. And it blows a lot of air. So we've got a lot of cooling effect here. So I'm pretty optimistic these things will keep running 24 hours a day.
Right, yeah. And maybe you can put a filter on it, and you'll have an air filter for your shop as well.
Maybe. So
I just read about plasma air filters are the latest rage. So. And what are you powering it with there? Now is that
I just got my voltage supply there over there.
And so I mean, what voltage are you putting in?
Well, this is a 24-volt motor, and this is 18. So
Okay, they're
I got that at 18 right there. So and it's well balanced all the way up to 18. So
yeah,
I'm real happy with that.
Wow, nice.
And the other one, it'll, and I measured the RPM on them. They're both, I can get them both up to about 12,000 RPM with the rated voltages. So
more than adequate for most experiments, except if you're trying to blow something up deliberately.
Yeah, so I got to mount my motor controllers on there and send down, get my shaft adapters centered and stuff. But so this one's sort of set up for that gold making experiment. So I'm gonna get my bottle of gold up there and my balls ants watered up the right way, and
just the new fiberglass balls there and so on. Jeez, eh?
Yeah.
Right on. That's a nice idea. Really nice.
So I made some little balls too this week, but they didn't turn out all that good because I found this mold over at the fiberglass supply store, and I used that. It's just a one-sided mold, so they came out pretty rough. But I'm going to make a two-sided mold that squishes together to get a nice smooth ball.
Right.
And so I bought some silicone casting mold material. So
silicone casting.
Maybe next week I'll show you some.
What are you going to do with the silicone casting?
Yeah, it's a two-part. Well, I'm going to get a sheet of, I think that's 1/8" plastic that I've got. And I'm going to drill some holes in it, and that's the half of that little acrylic ball. I'm going to mount about 10 of these balls on this sheet, and then put a form around the outside edge, just rough wood form, and then I just pour the silicone casting in there, and that gives me my mold for the balls. Okay. And then I can turn this over, and I can do the other side. Get a mold for the other side, and then I can fiberglass my one mold, then put the other mold on top and squish it down, and I've got it should give me nice smooth balls, fairly balanced and centered.
I see.
That's my hope. So we'll see.
Well, cool. So now you have to be able to turn the whole thing sideways somehow. You need a hinge on your table. So, like, I turn my mine sideways for my experiments, but
but the gold will fall on the floor.
The gold would fall on the floor. Then you'd be having quite a time picking up that mess. Boy, you don't want your gold to fall on the floor. Believe me, I used to be a prospector, and when gold falls on the floor, it either disappears immediately into whatever nearest crack is available. It goes to the lowest spot wherever it is.
Yeah, and I'll probably put another sheet of plastic, another tabletop here to collect any dust that this thing creates or whatever, just to see if I'm creating matter with it.
Maybe you need like a Garrett gold pan mounted on top there. That tends to attract gold. It's the green color is actually really good. It's a plastic gold pan for those who don't know, and it's used it's pretty much the standard in the industry now. And it's green because it shows the gold better than a black surface actually. And plastic tends to attract the finer electrostatically attracted gold as well. So something to consider. Maybe you do need some sort of catch tray that's appropriate for gold. What would gold like to land on? A recently formed gold baby atom. What would it like to land on? So
well, we're going to try 1/4 inch type 2 plastic.
Sounds close enough. Yeah. Interesting.
Anyway.
Well, good luck with all that.
Anyway, I think I got a couple of motors there that'll spin, continuously.
Yeah. Yeah.
So
the bearings.
That was the goal, and then we can use them for whatever.
That's a really good point. Even my little sewing machine motor, which is pretty trusty, it's still a little warm for even that short run. It's not adequate. These are much bigger motors. They're probably close to a horsepower motor normally, and the bearings would be incredible on those. They're meant to really take a beating and keep on ticking. And of course the cooling with that massive fan on there. Yep, it's a good combination. Probably a little bit noisy with that fan. It's a little hard to tell. It overwhelmed your voice there a bit, but you could always you know, modify it if you wanted to. You could probably get away with a lot less cooling actually than they're used to. Something being all plugged up with dust and
Yeah.
you know, all the.
Well, that's what Brennan was saying on Monday. That's the problem they got in Indonesia. There is they can't find a fan or a motor that'll stay cool enough to run for like 30 days straight.
Okay.
Burn out. So
yeah,
maybe this will work. Maybe it won't. But I'm gonna give it a try.
Yeah. Well, definitely, it's sort of underused in this situation, or under pressurized. It's not stressed out, and running even an out of balance spear, it should be able to handle it no problem.
Yeah, but if this fan idea works, you could always make a casting of, say, this one and stick on other motors, because most of the other motors I'm getting are just got a little gear on the top. So they're.
And what size is the actual shaft on those Weed Whacker motors?
This one's probably about a 1/4 inch.
Yeah, it might be 10 millimeters.
Somewhere between 3/16 and a 1/4 inch. I've been getting motors from Electric Drills and stuff like that, because they.
Yeah, some of them are probably metric and some are English, depending.
Yeah, that one's got a gear head. This one drove another gear, and then the shaft was on the other shaft, so it was gearing down. And,
yeah.
And there's another one with a gear on it, but that one's got a fairly long shaft. I can get something glued on that to run. And this one's just got a small little gear, so that one's going to be a tough one to fasten to get it straight.
Yeah, it's hard to know what to do with the gear, how to attach to it. I got the same issue with some of the little remote control motors for cars. They normally have a gear that attaches, and then a spur gear and all that for the differential and whatnot. But yeah, it's a challenge to make things. But that's nice to see that little pocket on there.
Keep your eyes open for old weed whackers.
Yeah, I will. That's actually a good idea. I mean, I've used blower motors before from automobile for the heater blower motor. But then you have a shaft, but it's hard to attach to it once again. You have to have some sort of adapter, and that's always the challenge. So having that cavity in there and the screw top thingy and so on. Nice way to go. All right. Well,
Black & Decker, we say they've got the green on them, so they don't.
They've got the
best,
what?
But
sorry,
Black & Decker ones that got gearing on them.
Oh,
like
okay.
There's another gear on here, and then the Weed Eater shaft. So
I see. Okay.
They're not direct drives.
Right.
But
okay. Very good. Good info, Lee. Thank you. Anything else on that, or you got any other secret projects in the back of the shop there you want to show?
I got a weird situation here that you might be interested in.
Weirdness we're always interested in.
I thought so. Let me switch cameras here. I can find my mouse on the screen. There it is. Whoops. Okay, there's my Gantt shelf, which is above my computer here. And not set up right here. Come on, tripod. anyway, down the end here, I got a light for where I drive my Ganses. So this cord off this light goes up to this shelf and goes right to the back of the shelf, and then across the back and down to a plug. But the interesting thing is when I get my little tester going here, it starts beeping. I don't know whether you can hear the beep all across the front. And it's about 16 inches away from the cord. So somehow these Ganses are picking up the power.
Do you have any regular distilled water there as well that tests for the same way?
Not on the shelf right now. Well, when I pull the plug on that light, of course, I get no beep. So it was just interesting that, or I found it weird or interesting or whatever, that the Gans is sort of amplifying that electric current in behind in that wire.
Right, it is. That's why, water is known to pick up on fields, for example, and amplify fields, but it would be interesting to have a container of distilled water there and see if it does it.
Yeah, just a sec, I'll go get one.
All right. Great, we get to do a real live experiment here. This is what we like to do on this show. So
that's just distilled water poured out of a 5-gallon jug into another pot.
No.
So that one's beeping too. That's some Gans. So anyway, all the Gans bottles in the water, they beep. And of course, you go to the light, the cord, it beeps like crazy.
Right. Okay. Try the Gans water and then turning off the light. Or sorry, the distilled water and then turning off the light again. And is everything dead at that point?
So 2 bars on the tester. Unplug the light, and there's nothing.
I see. Mm-hmm. Interesting.
That's about, the cord's way up there, so that's about 2 feet away from the cord.
Yeah.
So anyway,
yeah.
Something for the weird file for tonight.
Yeah, well, definitely. There's been a few anomalies with electrical stuff and so on. There was an experiment I ran into recently with magnetic fields with Ganses as well, with putting a compass on top of the lid of the Gans in a mason jar. But I found that the lid of the mason jars were quite magnetic, and they tended to sort of deflect the needle and so on. You have to sort of retrain them and get everything lined up with the Earth's magnetic field and so on to even start the experiment. And there's too much iffiness to it for me to come to any conclusions on it. But it's a good one to do, is the magnetic and electric effects of Gans. I don't know if that's really been investigated to any scientific degree. Like we have the equipment to measure stuff. People that know about different types of fields have different types of measuring equipment, and we really should start doing more sort of scientific-y tests that show either an effect or no effect from certain fields with the Gans material, it seems. Okay, thank you, Lee. Thanks for the mystery as well. All right. Anybody else have something they'd like to do for show and tell time here? Surely people have been working all week hard on their reactors and are really excited to show something unusual. Maybe lift, for example. Hint, hint. Don't hold back. Now's the time. Okay, how about gold? Maybe you created a little tiny bit of gold and you thought you might like to tell the world, but have been too shy until this moment. Now is your chance. Not hearing you. All right, how about some other materials? Water, perhaps? How about an air bubble? I'll even go for air bubble. Okay, well, hard to get a laugh out of this crowd.
Okay, I'll jump in. Can you hear me okay?
Yes, Libby, yep, you're coming through clear.
Okay, so I did an experiment just using 2 zinc plates in salt water attached with bare copper wire. Neither zinc plate was nano-coated, but I figured, I wasn't sure. It was on a shelf, and below that shelf there's all kinds of GANS experiments that I've made over the years. I figured their fields and everything might affect it, and there's this really beautiful grayish, whitish looking GANS at the bottom of this chart. And I didn't know what kind of GANS that would be. I was hoping to make zinc GANS. And unfortunately, it's upstairs. And I'm downstairs, so I can't bring it down to show you. And I guess I could more quietly. I'll come back.
we definitely got a good visualization from your description there. That was a nice addition. And thank you.
It was the flashing that we can get from Kent or Home Depot. So supposedly it's good zinc. I don't know. Anyways, I was quite fascinated. I thought, well, will this alone, without any electrodes or anything else attached to it, create zinc? It's been there for about, I think hopefully I wrote the date on it, but about 2 weeks.
Mm-hmm.
I'm just letting it sit there. So could that be zinc oxide?
Oh, definitely. I think so. I mean, you've got the 2 plates. You're going to have some potential between them. They're going to be working between them, especially connected with the copper wire. You've got a potential that gets set up there. There's definitely room for action, and zinc and salt water, you're definitely going to get some sort of interaction. Now, your copper wire would be out of the water, is that correct? And connecting the plates, yeah.
And it's a coil. It's a coil copper wire. But it's thin, I think 20 gauge wire, maybe 22 gauge wire. Very anyway, it was fun because I don't have the means for electrodes or any of that stuff. I thought, well, simple, you like simple. Let's just try this. So, okay, good, thank you.
Nice, okay. All right, anybody else with any mysterious stories to report?
Well, I have one.
Okay.
So I have a question. I have a kind of question. I was wondering who would ever show if they had a lift or any significant action in their own environment, and then they would reveal it all by itself, all its nakedness. And then they wouldn't be worried about the next day what would happen to them. In terms of, we're hearing Mr. Keshe has had many threats, many life-threatening experiences in his own time, and he's still perhaps having it without telling it to us. What is the guarantee that we wouldn't have if you ever reveal anything to this program? And maybe there are many people who are actually holding it back. Maybe they have been threatened and they're not revealing. And just an example, and I'd like to find out about that, perhaps.
Well. That is, that's definitely a possibility. You can look at throughout history, and there's been many inventors that have been threatened and possibly even lost their lives in their course of their inventions. There's several cases that of Stanley Myers that may have been poisoned, for example. And he met with two Belgian businessmen that were interested in his invention, that he was able to drive a dune buggy Volkswagen across America on, I don't know, 20 gallons of water. And these Belgian investors came to talk with him and so on, and his last words were, "They poisoned me," before he died. So that may be, there's other examples as well. And we have Mr. Keshe and other people. I mean, look at Tesla, the things he went through in his life, and various others. However, having said that, I don't feel like I've been suppressed or harassed in the past 4 years of doing stuff on this show, and other than when we were dealing with Sterling Allen and he sicked his lawyers on us and had the live stream taken down. We lost the live stream and our videos and our subscribers on live stream, and that happened twice actually on the live stream channel. But that's a different thing. There was basically, it's got to do with you know, you're not allowed to mention people's names and call them names and stuff on live stream without you know, they can harass you, and as soon as the lawyers get involved, bingo, they just take down the live stream and let the dust settle and let people figure it out from there. They don't care who's right or wrong in the situation or anything like that. They just see that there's legalities involved, and it somehow shouldn't have gotten to that point. Someone got angry and upset enough that they got lawyers involved, and that means Livestream doesn't want to have anything to do with it, and they just shut down the whole account. So that's you know, a possibility, but we're living in a bit of a different world now, and it's not as sort of controlled and so on as you might like to think it is. Someone just mentioned you can't shut down the internet. Yes, that's true. That's one thing, and you know, most people that are involved in this, supposedly in this business of eliminating inventors and so on, if you think about it, probably about the worst thing that someone could do would be to eliminate somebody like Mr. Keshe or others that have special information, because almost everyone that's in that position has a, what do they call it, it's a
dead man switch.
Dead man switch. Thank you very much. That's it. Exactly. And what's a dead man switch? Well, that is if I die, then I have this file that gets put on the internet of all my secrets, and it goes out poof into the whole internet, and you know, all that stuff that got held back for a gradual process and so on just gets suddenly strewn onto the internet. And that's the possibility or threat to those organizations that would go in and try to squelch people now. In the old days, you could get away with it. You could send a hit person, or, you know, if you controlled all the media, then that person would have no other way of getting the information out anyway. And if you controlled the patent office and whatnot, and basically you could shut down, you know, people could shut down others. Now it's more difficult to do, first of all, and you know, we're in a funny position right now where if someone did come up with a you know, a flying saucer in their garage and they were demonstrating it, first of all, it probably wouldn't be believed on YouTube, and most people wouldn't even bother them. And second, if it did get believed, it would probably get, you know, instantly promoted rather than shut down. And
you're actually safer. You're actually safer bringing it out and sharing on the internet, getting it around to 10,000 people all at once, than sitting on it. It's the people who try on it that
That's
get.
right. And that's the decision I had to make years ago. And you know, I'm normally not a extroverted person particularly, and suddenly I'm involved with you know, dealing with publicity on YouTube channels and Facebook and all this kind of thing. And you have to come to like a certain rationalization or agreement with oneself that it's all okay, because basically you're doing something that's number one, to helping others, helping other beings evolve, and helping them with their physicality life, and helping with creating new constructs of culture and society that are of more benefit to more people, and the easing into a peaceful culture and all this kind of thing is actually a very protective environment to be in. It's like, you know, if you maintain that mood of peacefulness actually, and not, you know, not expecting or wishing or ready to fight all the time and try to fight for your point of view and fight for getting the technology out or whatever it is. It has to be done on a much more subtle basis, with a certain kindness and gratitude and a sense of non-greed involved with it. Because once the greed gets involved and other lower emotions like that, basically, then you don't get very far in this technology. I don't think it. I think it backfires on you if you try to use it for greedy purposes. So I think that we're living in a different culture, a different time now, where it's acceptable to have alternates to, especially to the oil industry. The oil and that whole thing is in big trouble right now. They know it, and they see the writing on the wall. We're phasing out of the burning of fuels, and that is a fact, Jack, and you can't get away from it. And you might want to have more pipelines put in, but I guarantee you, by the time those pipelines are put in a few years, it takes a few more years to have it all come through and put them in place and have them up and running and all that. By the time that happens, oil will be obsolete. There's already, last week, 4 major cities of the world, including Athens, Greece, Mexico City, what's the other big one? Paris, France, have all agreed to eliminate diesel in their cities by 2025. That's only, 8 years coming up or something. Less than 10 years, they're going to phase out of diesel fuels, because they know now, they've realized the health issues involved with these kinds of fuels. And they realized due to this huge debacle of the Volkswagen and their cheating on their fuel emission exams, basically they've destroyed the entire market for diesel vehicles. And what it did is it made people examine the situation more closely. And, you know, what's the repercussions of a vehicle that puts out, say, 40,000% more exhaust emissions than it's supposed to? In the case of Volkswagen, 40 times more emissions, which is 4,000% more. That's not acceptable, and people are examining, well, what's the repercussions of this? Well, you can actually nail it down to so many more people die because of that additional emissions, so many more people get asthma, so many more kids get cancer, and so on. The list goes down. And now they're starting to see, okay, it wasn't about the CO2. The CO2 was what they call a smoke and mirrors show. To me, it's one of the greatest smoke and mirrors shows of the 20th and now 21st century. And it continues to go on. We are continually diverted into believing that CO2 is this horrible gas that we need to get rid of. We need to bury it in the ground. There's a good idea. Leave all the other toxic gases in the atmosphere and put the CO2 in the ground so the plants can't use it. Blah! That's like the most dense, stupid thing that I can possibly imagine to do with CO2. But this is the mentality that's come out of this CO2 generation. You got to realize I'm an old fella, and I've been there watching this whole ploy occur over the last 30, maybe 40 years even. And there's been a gradual process. Started out with zero tolerance. Zero tolerance now is used for drug policy. We have a zero tolerance on drugs, and it's everything zero tolerance. You say zero tolerance, it's associated with drugs. It used to be associated with the trace toxins in the environment. And we were supposed to have zero tolerance for DDT and for all the toxic elements that were getting into the environment that they were starting to discover in the 1960s and 70s. And so they said, okay, we have to have zero tolerance for all of these things, otherwise they're going to spread into the environment and everybody's going to get cancer. Oh, okay. And that lasted for a year or two, and then they diverted that term zero tolerance into drugs instead of the environment. And we forgot about the environment and let all that stuff sort of, we sort of regulate it and make people pay fines if they dump a lot of stuff into the environment and so on. And so that's one phase. The next phase comes in with this whole global warming thing that started to, the possibility that the globe is warming. Okay, sure, the globe's warming. There's not much doubt about that. So our other globes are warming. Turns out Mercury and Jupiter and Mars and a bunch of planets. In fact, just about every single planet is also warming. Are we going to go to those planets and fix their environments too? Because everything's warming for some strange reason unknown to man. Well, duh.
And you had to smell a rat with global warming when instead of cutting down emissions, they just monetized it.
Yes, they start claiming this carbon credit business and so on, so you can essentially buy off the government in order to pollute. And it doesn't affect the actual emissions that people are taking in.
Yeah.
So what happened was with the CO2 thing, see, the reason I brought up that I'm an old coot is that I remember why they brought CO2 into the equation to start with, and it had nothing to do with global warming. The reason they brought CO2 up is that it was a marker gas for the other 200 toxic gases that are involved in motor vehicle emissions and emissions from industries and emissions from trains and all of that stuff. The CO2 just indicates how much combustion happened because our engines are a certain, 23 to 30% efficient, and it's the equations add up. If you burn this fuel, because all fuels, when you burn them, give CO2. That's part of one of the gases that are involved. But there's also 200 other gases, and most of them are extremely toxic, where CO2 is not. The people that die from CO2 every year are, not very many, and it's because they're in an enclosed space where there's no oxygen, and they breathe too much of the CO2, and it's, the lack of oxygen kills them. And there's probably less than 20 people a year or something die from that. I don't know what the statistics are. So the fact is they use CO2 as a marker gas. They're supposed to indicate how much burning was going on, and that was an indication of how much nitrous oxide, nitric oxide, the hydrogen sulfide, and the all the other ides in us, and the other gases that are involved in burning that are extremely toxic. They are not accounted for in this whole CO2 thing, and they've diverted CO2 into global warming, and they say you have to get your personal CO2 quotient down by stopping certain things, and you know, industry has to find a way to get rid of the CO2 that they give off, and so they find ways of getting it out of the exhaust flume. They take the CO2 out, but they don't take the other toxic gases out, because if they did, they wouldn't know what to do with them. Well, actually they do. What happens is that's ends up in the basically it gets fed back to humans. they use the scrubbers from the natural gas power plants. They scrub off the toxins from the exhaust, because they're not allowed to give off too much toxins in the exhaust. They scrub that off, and these mats are a way of filtering the exhaust, and they make that into fertilizer. They make that into fertilizer, so that 90% of the fertilizer from North America comes from these scrubbers from natural gas power plants with all the toxic stuff in them. Cadmium, mercury, you name it. It's all in there, a wide range of stuff. But of course it's also high in the phosphorus and potassium and so on, or nitrogen in particular, which makes it a good fertilizer. Well, that's a shame, because what they do is they fertilize all the forests of North America by spray bombing it with this crappy fertilizer, and builds up the toxins in the soil and in the trees. And then you have a forest fire, and the smoke from the forest fire is toxic because the trees are toxic. Hello? And and meanwhile, all we worry about is CO2, that the world might warm up a tiny bit more and the ocean might increase another centimeter or something, when the actual statistics from the UN that due to the burning of fuels, over 5 million people died last year due to the burning of fuels, and 5 million the year before that, and 5 million the year before that, and the year before that, and the year before that. Every friggin' year. Think about it. Past 30 years, 150 million people dying. And that's just a conservative estimate from the UN. That means 10 to 20,000 people every day dying from this crappy air that were forced upon us from the oil industry. And that is the part of the equation that has not been taken into effect, and that is about to be a complete wave that's going to overtake the whole oil industry. Because when government and individuals tie in the health costs due to the oil industry, and they are getting tied directly now, because the scientists have just recently discovered the carbon nanotubes that come out of the diesel exhaust. That's where they found carbon nanotubes to start with. These wonderful, miraculous carbon nanotubes. Oh, what's this in the diesel exhaust? Oh, that's funny. Buckminster fullerene form of carbon, wrapped in a tube. And it was found in diesel exhaust because of its high pressure and high temperature. So now scientists have discovered that these carbon nanotubes actually exist at the site of the lungs with kids with asthma. And they can identify now, these carbon nanotubes, that they come from a particular fuel or a particular vehicle. They can tag these carbon nanotubes. They're basically tagged from certain fuels, certain combinations and so on will create particular carbon nanotubes, and they can actually tag it back eventually to individual engines or manufacturers and so on. So basically, the manufacturers and the oil industry, they have a defective product that they're getting nabbed for. Unfortunately, most of them are under, they're not allowed to be, under lawsuits and so on. But you're going to see massive class action lawsuits going on, and you're going to see they're going to have to pay back the health costs, and it'll be in the multi-trillions of dollars, if not more, multi-tens or thousands of trillions of dollars. Healthcare costs are the greatest costs now for virtually every government, and rising exponentially. So it's a very serious situation. And so that's why we've got governments and others that are realizing they've seen the writing on the wall, and they know it's time to give it up, and they know we're going to electric vehicles and self-driving vehicles. That's the way it is. That's the way it's going to be in the next 5 years. Every manufacturer will have self-driving vehicles. Tesla car company already does. Every new one coming off the assembly line has fully automated driving capability. It just has to be activated. You can get in and have it take you to your destination. Take me to the pizza shop, whatever. And that plus the all electric cars, which will be the rage of they're already the rage of the future. The best cars in the world are electric now. The fastest cars, the quickest cars rather, in the world. It's the Tesla electric car is the quickest car in the world, quickest sports car in the world. You can buy one yourself. It's a new world we're moving into, and it's electric, it's self-driving, and that's going to mean big changes for the Kesh technology, for the plasma technology, because that'll be the next step. Because now, once we have automated driving vehicles, and they're all moving around, for example, Uber, the taxi company, they just put an order in for a million new Tesla cars, Tesla electric self-driving vehicles. Imagine 1 million. And this is the way of the future, and people, they won't want to drive, and especially when the insurance companies are going to charge you more if you want to drive yourself, because the self-driving cars are already proving to be 50% safer than the human driving. So once these vehicles are pervasive in our environment and everybody's going around these self-driving vehicles, then it's an easy transition to the next stage, which is going vertical. A vertical and being able to move in 3 dimensions instead of 2 dimensions on our roadways, which will be just getting too congested. And so if we have the same technology that enables these self-driving cars not to smash into each other, if we apply that to 3 dimensions, we'll be able to have vehicles that travel in 3 dimensions and aren't smashing into each other, which would be a real problem if there was a lot of them. And especially if there was people like me and others on a joystick trying to drive at Mach 40 through traffic. It's just not going to happen. You can't not have humans behind the wheel or joystick or whatever it is we use to steer our saucer technology with in the confines of the atmosphere. So that ain't going to happen. It'll be all automated primarily. And now that we have the systems that are already implemented for the automation, it's easy for governments to allow that technology to flourish now. So they're going to be wanting more and more of the alternate technologies and the move to 3-dimensional movement as well. This is all, instead of being looked upon as something that's intruding into the oil industries or competition for, or something that's That's scary for the oil industries. Now they're looking for alternatives. The government realizes that the money they get from oil now must be put into alternate technologies to build them up and replace that oil. That's the only way they have to make the transition, is to try to use the massive profits that are made from both the oil and the taxes and all that stuff to leapfrog into the next step. And governments realize that they're just not... Don't you
reckon these guys are the guys who've been buying up all of these inventions for the last 100 years and putting them on shelves, you know? These will be the guys who'll be pulling that technology off the shelves and they're just trying to, you know, figure out how to make a dollar on it.
No, they can't, because number one, the spread of the knowledge is too fast right now, and number two, there's too many rich people that want to go to space. Bottom line. So now they want it.
Well, one argument that I've heard lately that's kind of rings true to me is that one of the reasons they won't bring this out because they're concerned that this technology can be weaponized, you know. They don't want someone down the street who can make, you know, can turn this into a weapon.
That's right. That's exactly why the technology for the self-driving cars is implemented. I mean, you're not going to have. It's a way of controlling the population in a sense, you know. We're going to have to control the population, or the population need to control themselves in order to implement this technology. This is the whole thing about the Keshe Foundation and Mr. Keshe, is we have to have global peace. We have to have peace in ourselves and as a culture in order to fully implement this technology.
Yeah.
And the other part of that is it's a Pandora's box, and once you open it, then all the parts start coming out, all the entities start coming out. So if that's true, and we've already opened the box, we're already pulling parts out, it's all already out into the environment. It's just a matter of people pulling together the pieces and having them fit together and go, wow, okay, this works, let's, you know, market this. Wow, that's really cool. And that's essentially what's happening. And there's no way a major corporation can, you know, buy it up anymore or block it, because it's out there. People want it. They know it's out there, and it can't be blocked because people are working differently now. It used to be they could block by the patent, you know, situation. It used to be you could never do anything without getting a patent and whatnot. And now we have companies like Elon Musk of the Tesla car company that's giving up their patents. They've decided to make them public and share them rather than keep them for themselves and, you know, making the massive profits on their private patents. The Tesla car company used to have the patents up on the wall of the lobby when you go in, apparently, with, you know, all their special patents, and they had a lot of them. They're, you know, it's a highly innovative company with lots of really cool things that they've made as engineers. Elon Musk is an excellent engineer himself, but his whole team is just amazing. And what they've done with that car is incredible. So what they've done now in the lobby, they took all the patents down and they put up some other nice pictures or whatever. And now it's a totally different atmosphere. They're willing to work with anybody else. They show all the other electric car manufacturers how they make their chargers and how their systems work, and, you know, their motors and everything, in order to have some standards in the industry, first of all, and to make the technology more pervasive. Let's get it out there. Let's get this happening, you know, rather than...
Yeah. Wow, that's cool.
Let me just finish. Just yesterday I read that Elon Musk and some others, they are also working with artificial intelligence software and they just released all the and Google as well released the code for their artificial intelligence software yesterday or the day before. And so now this is, again, it's all open source, you know, public domain type of philosophy. And this is the way of the future, getting the public involved, allowing them to you know, to go with it as much as possible. Let's get the ball rolling and not worry so much about, oh, if I keep my little market share, then, you know, this is the most important thing for my company, and so on, to keep those patents for the 15 or 20 years or whatever, and try to, you know, make sure no one else does it, and make sure you let them know if they do it, they'll be in court, and so on and so forth. This threat, this fear-based, fear and capitalistic, greed-based culture is going by the wayside, and it's not working anymore. And the big corporations are realizing that. They're like big dinosaurs right now, and they're lumbering along. And instead of global warming, they're getting global cooling. It's snowing on them real bad, and they're looking for food, and they're just not knowing what to do. And some of them are actually getting a bit of a heart as well, because some of the people that are taking over the reins of the company as the old timers pass away and so on, they have a different attitude, and they might be more environmentally conscious or just plain conscious, and they're doing different things. They want different things done with the money and so on. So yeah, there is a lot of grounds for hope in that realm.
I was just going to ask you if you've you know of John Keely's work in the 1860s. He did the water implosion machine, or he built a lot of water implosion devices.
Yes, I just looked at that last week, one of his devices that was restored. And
so did I, Dale Pond,
Yeah, that's it. Mm-hmm.
Yeah, that was so cool. But
I looked
behind it is brilliant. I mean, he had a pump with no moving parts. And from what I gather, it just worked on compressing the air in a valve, you know, in a bell.
Well, it did have some moving parts, but the idea behind it was not so much the moving parts. The moving parts just facilitated.
The pump itself, the very first part of the machine, the water goes into a bell, and I guess it compresses the air, and then gets pushed out through a ball and socket valve, and then it repeats itself, and it just basically worked on water hammer and creating a resonance in this water hammer that built up.
It took advantage of that water hammer effect, which is basically the cavitation again, and ties into sonoluminescence as well. So I listened to that whole video. What was the guy's name again? Dale Pond. Dale Pond, for people that want to check that out. And he actually rebuilt the device, and it's all funky with these different levers and so on. You crank it up to get it started.
He said he built something like 120 prototypes of this one device. And they're not sure of like how late in the process the one they got was, whether it was, free from the finished device or whether it was the finished device. They've got no idea. But it's so critical. They're still not completely sure how it operates 100%.
Yeah, they took it all apart, and it took them several years to figure out the principles involved in it. This was in the 1970s, I think, when that was done.
It's an old video,
So, and they were going to try to duplicate the device and run it. They didn't want to run the original because or not for very. They ran it briefly. They didn't want to destroy it, or they need to keep it for posterity. And they were trying to raise funds in order to machine a new one. It would cost several $1,000s at that time in the 1970s when money was worth something. So
I went on to Dale Pond's site to have a look at if he'd done that, and on the very first page of the site is an advertisement for a reward for the turn of the stolen machine.
Oh, no, is that right?
Yeah, yeah.
Oh my God.
I read that, my head dropped, and I went, "Oh no, no way!" You know, really sad. Yeah.
Yeah, it is. Huh. Jeez. Humans are
You know,
weird.
he's talking about they fired it up once. You know, it had
Yeah.
burst pipe things. They replaced that. He fired it up in the bottom of a bathtub, and he said this machine became alive. You know,
Right.
they could
Yes.
prove it
That,
enough to see
thanks for
that it
saying that.
worked.
Thanks for saying
Yeah.
that. That's a really good point. That it became alive. That it actually he was sort of couldn't find the words exactly to say what he wanted to say, but it became alive. It was like because it had a lot of parts to this thing, and it wasn't just one simple water hammer thing. It had another section that also worked on water hammer and collected it in a different way and so on.
Yeah.
So it took
was
advantage of.
incredibly perfectly machined. This guy had an understanding of machines and to create things, and the tolerances would have been just minute.
Yes, right. He was a machinist,
Part of
apparently.
it microwaved. There was a microwave resonance chamber on the right side
Right.
of the second part of it. Yeah.
Right. This is way before microwaves, of course, too, and somehow he had intuited or discovered how to work with the microwave resonating cavity, essentially, inside
I think it
of
took
this
us
machine.
about 5 years to figure out what that was.
Yes, that's right. And so, once again, we have a reactor that's reacting to the point that it makes this person, 100 years later, feel like it's coming to life when he fires it up. That's pretty fascinating, and we definitely have plasma involved in that device as well, in spite of it being 150 years old now or whatever the heck it is. It has a plasma life. It's got maybe that's what it takes when we say a machine is coming to life, that it seems to have life. Maybe that means it has a plasmatic connection.
Well, I mean, what I got out of that video is the way he was describing, this guy, he said he wasn't sure about this, but after he cranked it up, he decided he's going to spend the next 10 years or the rest of his life figuring out how this thing worked, and working with the knowledge from John Keeley. And I've just come to realize that and he was saying in that we've actually lost knowledge in science, and they approached it in the mid-1800s as sort of a holistic science, nature-based thing. It's like Kesh, it's an overall concept of the way the world works,
Right.
And I want to go back and study Walter Russell and Keeley and Tesla, because those guys were closer to what we're doing, and
That's
I think
right.
maybe there are some answers back then that we can use now more so than the modern stuff,
That's right. There's things where
science took a turn for the worst. We're still
right.
paying for it.
Well, we got sidetracked into a lot of other detail and various things, but some of the basic principles got sort of glossed over or missed or ignored.
Yeah.
And sometimes maybe deliberately sort of, swept under the carpet, as they say. And that's... I found that video actually quite inspiring, and it's similar to what I'm doing with my spheres here. That's what
made me think of it. When you were showing that, I thought of this video.
Yeah, and I want to be able to take advantage of some of these characteristics and idiosyncrasies of water, and one of them is this water hammer effect, and that's a strange thing that mankind has spent a lot of time and attention to get rid of in our culture, and maybe that's why we don't hear of it so much. But yet, water hammer is something in your pipes. When you turn on the faucet and you hear a thud or you know, bop, 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 bop. You sort of, actually, it's more like it's an actual banging kind of noise that can happen in the pipes down in the basement or some other part of the plumbing system. And it's due to when you open a valve and water flows through the valve, that sudden rush of water going through or water stopping against the valve. Say you have water rushing and then suddenly a valve closes and the water stops, then that shock wave starts rebounding back up the pipe, and on the other side of the valve you have when the water's moving along this is the valve and the water's moving this way, and you shut off the valve, then that water, there's a voidness that occurs, a little vapor bubble, a nothingness bubble, and that forms and then implodes on itself and sends a shock wave the other way. So you have shock waves going both ways.
So that resonance going, and it adds to itself.
Yes. Mm-hmm. So I mean, it's incredibly destructive. It can burst open pipes, and on a local level, it actually etches into metal. It can cause, you know, the cavitation can erode stainless steel, just rip it right off the surface of the metal. And
well, they said, Dale Pond said that Keeley, while creating this device, blew the side out of his lab, blew the wall out of his lab with it. You know, that's pretty impressive. Just water, Yeah,
there was one story of a tube that was in resonance, some sort of resonant tube of water, and they hit a certain frequency or whatever, and the contents shot up through the roof and left a tube-shaped hole through the roof. So play careful out there, people. We might tie into some forces that are unusual or unexpected. And that's what I'm hoping to do. That's why I've got my polycarbonate cover here, which I've already proven to be able to take the hammer blows of a ball peen hammer without cracking it or hurting it, other than a couple of little dents.
Before, if I got threatening phone calls, I'd be really happy because it means I'm onto something. You know?
Well, that's right. You should be happy when that happens. The more threatening, the better, because that means you're just, you know, irritating somebody on a higher level, and that's all good. You know, this has been the story, but I literally have not been threatened or feel like I've am under threat, other than a few trolls that have been annoying along the way. But most of them have taken care of themselves when I follow the two magic words that Mr. Keshe taught me years ago when dealing with trolls, which are ignore them.
Yeah. Well, I've been getting
it's the hardest thing to do.
On the Golden Age of Gantz, I've had about 20 friend requests from very attractive young girls.
Oh, yes, and that's the other one.
The profile, and, you know, there's about 2 pictures and about 3 lines, and you realize it's a non-event.
And they just changed their profile picture the day before into some real snazzy looking
and if
lady.
If you don't follow through with a request, it's gone in about 10 minutes.
Yeah, because it was
move it real quick, so you can't complain about it.
Yeah, that's right. So yeah, you gotta. And some of those could be spies that are trying to get information, or, you know, otherwise harass and whatnot. Or more likely, instead of harass, they're looking for ass, and mostly yours, and not for sexual purposes, but because that's where your pocketbook is, in your wallet, and that's where they want to separate you from the gradient of your behind and your wallet in order to extract money from it.
Unlike you, I'm an old guy. I've been around the block, you know. I've seen all that.
Yeah,
I know they're not after my body. Yeah.
I keep thinking that, but hey, it's not true. Wake up, you know.
It's good. Yeah.
Yeah. So, I mean, that's the.
Wait a minute now, everybody. We're old, but we're still worth something.
And all the body parts are still functioning too. So.
Thank you. Let's not discredit ourselves and stop these young people from telling us that we're old. We are old never. We are a part of the universe. Whatever time lapse we are in, and they are in, and they are in. There's no time but the present.
Right
Beautiful,
on. Thank
Mark.
you. Thank you for
Yeah,
that
well
reminder.
I'm just happy I get up in the morning, nothing drops off.
Yes. Yep, that's
Wait
right.
a minute, Tony. Tony, now I've got friends and I've got neighbors that are in their 80s, 90s. I don't know anybody in their hundreds yet, and nothing has dropped off. Nothing. The grass. Okay. I have a friend of mine's grandfather who's 93, and he says, if I can't do it, somebody else will.
Yeah. No. Hey, we've all got a bit to go yet. You know, still on the roof with a power saw and 30-degree heat. You know, it's not too bad.
Yep. And my uncle was still dancing up into 92 when he passed away. So that's important too, to remember to smile, dance, and have fun.
Yeah. I don't think anything's going anywhere anytime soon.
Yeah, it's an interesting thing, and I don't worry about threats and all that anymore. And if I achieve lift and start to show the world, I know there'll be all kinds of friction at the same time as blessings and so on that come out of it. I mean, that's part of the struggle of this technology in one way or another. And it is a factor, this idea that we have to make the space safe for people on planet Earth, and we can't introduce technologies that are too far advanced because somebody may misuse it and so on. But if we introduce it gradually in a way that misuse can't happen very easily, let's say, the systems won't be available, the high-tech control systems and so on won't be easily available to those who are just playing around with it. And in the same way that, you know, getting hold of an actual jet and driving it into a building like was done in 9/11 is not that easy of a thing to do. Most, you know, you'd have to hijack the jet or build one yourself or buy one yourself or something like that. And it's all of those things can be done, but they're not done on a regular basis in spite of the abilities for, you know, certain bad guys to do that, I suppose, if they wanted to over and over. You know, we do have problems with the new drones that are coming in. People are able to fly them very easily, and cameras on them and so on nowadays. So there will be, and there have been and will continue to be drone incidents, and they'll have to be regulated and controlled more, which is again what's being done as well. The initial response when the drones came out a few years ago was, oh my God, we have to shut down the airspace for these guys, and okay, no drones are allowed anywhere basically. And then they opened it up, and as long as it's under a certain altitude, then you're allowed to have drones in certain designated areas and whatnot, and special permits for those that need to do photography and different specialized events and whatnot. And now
they've played a big role at Standing Rock with
yes,
the Indians having their own drones.
I was just going to mention that. It's made a huge difference, actually. Say again? Mm-hmm.
It's been a key thing for them to be able to keep the police honest when they know they've got a drone in the air, that everything's being filmed, you know?
Yep.
It's really key part, and being able to see what they've been doing, you know, in preparation for the crossing to the river. You know, they're being able to keep track of what's happening.
That's right.
And they're hating, you know, they're trying to, you know, say all kinds of things that they'll use in their drone to attack helicopters and ridiculous stuff like that. But there's lots of good reasons. You know, I've seen them used at a conference that we have out here. You know, 6,000 people conference where they filmed it and just provided a different angle for the conference video at the end. You know, and they've always been used for real estate photographs, things like that. There's a lot of good. Like anything else, it's a tool. Can be used for good or bad.
That's right. So we've kind of gotten used to drones. I mean, you can buy a drone with a camera on it in your local drugstore now, or any popular store basically, and it's become all pervasive. It seems every kid's got a drone with a camera on it, and they're putting it to strange uses. But part of the reason for bringing that up is that's a new technology that is just an example of a new technology that's come in that it could be really dangerous. What if ISIS was dropping bombs from drones onto people's homes in North America and they were all burning up and getting bombed and stuff? Then that would be a major issue, and there would be laws and regulations and more attention put on drones all of a sudden. But because that somehow hasn't really been that much of an issue, then the development of drones has progressed actually very rapidly. There's hundreds of companies now that make drones, and they're buying each other up and getting bigger and bigger. And of course, the military is part of that as well. And there's the military versus the private sector is a big thing in drones now. So all of this starts to lend toward the ability of us to fly, basically, because the government's forced to look at this situation. How we control these drones? How do we regulate it? And now they have to look at self-driving cars. How do we regulate that? And it's a natural step into self-driving drones that especially if they don't have propellers, because propellers have always been the big problem with larger drones, because propellers can chop things up, and they don't do well around trees and kids' fingers and stuff like that. So once we have a technology that is positive positioning, and we can move from place to place, and it's proven safe, that it's reliable, it's safe, it's not, people are not falling from the sky all the time and so on. Yes, there will be accidents, and yes, we have to be careful initially, especially to make sure that it doesn't go in disfavor for the public and for corporations and governments and so on. But still, because of the things that are already going on, it's lending toward a natural transition into a three-dimensional space for movement of humans that does not require the airports and airplanes and ridiculous wait times and technologies that are involved now. I mean, it will require tracking each individual. That's a no-brainer. It's already happening in most cities anyway. They have face tracking, and you can hold up your phone in, Toronto or other places where they have face tracking in the city, and basically anybody who's in that zone, you can tell who they are, and you can face track people easily, and who your friends and people who might be questionable are and so on. Who to hang with and who to keep away from that way. And it's the same with this new technology. It'll be automated to the point where we won't have to worry about the misuse of it, or not worry very much about it, because in the same ways we don't normally worry about a bus driver going haywire and killing hundreds of people by driving into crowds or whatever. It just doesn't seem to happen. So in that same way, it'll be a natural transition into the new technology that way. Go ahead, sorry.
Because I live in Detroit, and I've been in, for cars, and you went to Flint, and we just expect a bearing to do what a bearing is supposed to do. We expect a U-joint to do what it's supposed to do. We expect all these things. It's amazing, absolutely amazing, how the moving parts that we expect to do what they're supposed to do on an everyday basis that we rely upon as humans each and every day and we don't even think about it. It's a given. You're explaining a given. It's like a double entendre. We don't even think about it. Everything works, and we expect it to work because so many people before us have did the due diligence to make these things work for us. We stand upon the shoulders of other people that have came out of the cave.
Yeah. And we should be thankful for those that worked with the oil and got all that technology going, because in a way that helped us to leapfrog to the point where we are today. And if it wasn't for the wars and so on, and the huge leapfrogging of and jump forward in technologies that were brought on by the wartime, we wouldn't be able to be in the position of replacing the oil-based stuff.
The next step from burning stuff.
Yes, right. So
I'm so behind you because a long time ago you said, because I'm from the most polluted part of the states where we started the pollution from, burning something to make something to keep us moving. We as the in between, or the next step from the bicycle to the Henry Ford to the car to the burning. We are absolutely at the point where we don't have to burn stuff in order to make stuff.
And that makes me angry because I think we have the capability of doing that 50 years ago.
Well, that's right. That's right.
Technology. Just look at the progressions of aircraft. From the Wright brothers to what we've got now, military, commercial. Look at telephones, the way they've moved ahead. Every area of technology has moved ahead except fuel. There's no reason that we should.
Wouldn't everything else be 10 times the 10? If we had 10, every time one came out, it equaled the 10. So 1 part times 10 exponentially moved us to this point in our time. We would have never had this. We would have never had this progression if we wouldn't have had the people before us. So one guy made a discovery, and it gave 10 points to that discovery. You could designate any point. One discovery equals 3 points, 5 points, 10. So they used in an engineering form here. They said if we created one new form, it would exponentially turn into 10 new forms. It would make a complete. You could, from every new idea that we could create 10 new ideas. And now we're to the point where those 10 new ideas are so coming at each point so fast. Could you imagine, like, in 1935, when the guy said, we're going to go, or Henry Ford, when he said, if I could make the car and exponentially 1.10. He said the man makes the car, one man makes the car, he makes 10 points. Meaning that he can fulfill 10 points of the star that fast. And if you add that to the growth from then till now, it would be just, the math would be huge. That's why we are where we are today. We would never, the people back then would never expect it. I have my mother is 91 years old. She could not, she's like Henry Ford. You know what I'm saying? 91, she can't even believe what a cell phone or a computer, but yet she's, to her friends who are left, they say to her, how can you do this? Well, she's allowed herself to move forward 10 times as fast as what they would have done. Her brother, who was at 68, was the last child in the family. He says to my mom, who's 91, how do you do this? Because you allow yourself to do that because either you accept it or you don't. And like Rick said, we are accepting this or you don't. The authorities accept it or they don't. You either get on board and we can stomp it down and we can yell at each other and we can do all that, but it's not even worth it anymore. They used to not be able to do, they could do that because there was no, you know, do you want to send Paul Revere out on the horse and say, you know, whatever? No, now we can tell, with social media, we can tell everybody without Paul Revere. We are all Paul Reveres.
Yeah, and as humans, that's what we're good at doing, you know. We're good at, well, I mean, you know, you can call it growth. You know, you can stagnate and stick with the same thing, or you can grow. And, you know, as a species, we're really good at building on the knowledge and adding to it and modifying it and moving it forward. You know, that's one thing we're really good at, you know, and being able to pass the information on to the next generation, you know. That's amazing.
Yeah, and also what comes to mind is there's a different approach that's coming on in the last years. It's talked about that what's his name? Dale Pond actually touched on that too. He talked about the female energy in this machine, as opposed to the male energy that we normally, you know, as male engineers tend to work with. The male energy, which is more working with explosion instead of implosion, which is more the female energy, and with you know, mechanical as opposed to things that are more ethereal or plasmatic, let's say. So.
Yeah, I picked up on that too. That's what I mean. It's organic. Those guys were much more organic. They had a much holistic ideal of the whole structure of the way the world worked. You know.
Yeah, and somehow we got off on this more of a macho track of sort of a more competitive, more you know, showing how intellectual we were and how complex and cool machines we could build with even more parts and so on and so forth. The complexity became important.
Just because you could build something doesn't necessarily mean you should.
Yes, you know? Right.
We're going into some of the directions in AI and genetics. You know, it's like our psychological development is way below the level of technology we can put out. And scientists will say, well, it's not for me to decide whether we should or should not build this, it's just whether we can, is their kind of approach, you know? And that really concerns me of where that can take us with the abilities that we're getting now, you know? There are some things that, you know, you can approach it from a whole a lot of angles, you know? Whether we're playing God, you know, if you're religious, you might approach it from that angle. Or it could be, yeah, it's just, those guys in the 1860s, had more of a heart connection to the science that they were doing. They approached things in an organic way and a holistic way. That's not in this age that we're living in now, and that concerns me.
Yeah, well, I think we're getting more into it that way. Go ahead.
Just quickly, what we're perceiving is just like everyone's perceiving understanding in the same way. It could be in a very evil way. It could be in a very good way. It could be in a really, really terrible way. They could understand it and perceive it, this technology in every way. It's just what we're taking it from, how we're actually creating the platform to be able to perceive, and even our words when we're talking about it is making it, is creating it in another platform where we understand, or it's just like it's all our consciousness. It's a bit difficult to express it, but I dived in the middle of it. I'm terribly sorry, but I couldn't stop myself.
Hi, Alper.
Hey,
Yeah, go for it.
That's okay. We love you, Alper. But we want to know what Rick has got going in that glass box there.
I know, but
Move it, brother.
it's just beautiful. The reason I wowed it is just because it you could move the whole contraption in 360 degrees. That was the significance to me, and at the same time you're being able to inject something into it, into this bubble where it's all being unified. It just needs a little fine tuning, and it all starts from that. It's all, he's done it. I don't know how to express it, but this contraption, this bubble, is everything. It's really amazing.
Well,
when you inject anything in it, what we need to inject in it, if we could actually create that component, hydrogen or tritium or anything, it's going to stay there, because you'll be unifying whichever the RPM concerns. As long as you move towards the 360, you'll be unifying it. Doesn't matter what the speed is. That's
right.
just what I was so excited. That's where that's so amazing. That's just it, really.
Yeah, and actually you remind me of something that I came up with recently, which is have Mr. Keshe has talked about deuterium and tritium and so on as fuel for our reactors. And what's come up recently is you can buy tritium. Of course, you could buy tritium in various ways because it glows in the dark, and that's what they use it for, is things that glow in the dark without having to charge them up. It's a constant glow. So they use it for in instrumentation on the dial for the letters and so on, to have it so it glows constantly in the dark. Well, it turns out you can get these tritium keychains. Okay, it's a tiny little tube of tritium inside of a polycarbonate sort of outer case, and of course you hold your keys on it. If you look it up, tritium keychain, it's one of the gifts that you can get this year and whatnot. And they come in different colors. There's blue and bright green and purple and so on. And so I'm thinking, uh-oh, just lost my live stream or something here. Can you still hear me? I think you can hear me on live stream, but I've lost my... Oh. Hello, can you hear me? Hello, can you hear me?
Rick? Yeah, you're back, Rick.
We had a loss of internet here briefly, it looks like. I think the live stream kept going.
Yep, you're back.
Okay, as far as I know, we're all back in order here.
That's scary.
Yeah, that's the scary part, is losing the internet in our lives.
Tritium's scary.
What happened? Okay, I think we're all back.
Don't say tritium.
Yeah, I said the magic word, didn't I? Whoops. Well, you can buy it online, so it's not like it's a big secret. And so I thought, well, geez, why not have that little vial of tritium and put that in the middle of the sphere and have it rotate at the center core. You've already got the prime element that's needed to start the reactor. Of course, it's pretty expensive for this these little keychains, and
Need it in a matter state or in a plasma state?
well, that's the problem. It's in a matter state in terms of, as far as I know. I mean, it's glowing all the time, so it is in a plasmatic state as well. It's in a partial pressure of the tritium and so on, so it just tends to sit there and glows. But
isn't everything a little bit expensive when you do these experiments?
I'll say,
We
yeah.
go to the thrift store, I go to this store, we go to that store, and then all of a sudden I put it in my little file, and I'm going like, oh my goodness gracious. It's a big file. It
incredible.
became a little file, now it's a big file.
Bought little things like this today and this thing today and some other nuts and bolts, and all of a sudden I got $56 worth of stuff that, whoops, just for my dinky little funky setups, you know.
I was at 50, yeah, 36, 27, 32.
There you
It all
go.
just adds up, doesn't it? But it's, you know what? If we don't do it, nobody else will.
That's right, and there's worse habits to have too. So you know, spend your money on used weed whackers and stuff like that. I mean, it helps keep the trash off the streets too, and it keeps things out of the landfills, and we do our duty to recycle that way, I figure.
It keeps us happy.
And plus, we're keeping the ping pong ball industry of the world going. That's important as well. Think of all the Chinese that we're supporting.
Thank you, Rick. Thank you.
So
The support of one another is everything.
that's right. You
It's
know,
amazing how many eyebrows of visitors, you know, rise walking through the house when you've got coils on the stove and you've got this everywhere. You know, it's like, and I'm sure all our houses are starting to look the same, you know.
yeah,
Tony, my family loves me dearly, but they are at the point where they're questioning me.
Yeah.
yeah, well,
That's okay. I love them and I send them out. You know, once this is all done and set over with, you know what? This is a fun experimental thing, and my family, like, they think of us. Are we crazy? Yes, we're crazy. We're crazy for the future, the fun of the future, of something that could be. We reach out to the stars. We're like fortune tellers, and we're so happy to do it. And that's what last week, let's just keep fun in our hearts. I got so much to share, and I want to share it with everybody. So anybody that wants to go first, go first.
good
Sorry.
one, Mark. That's right. We are the high-tech shaman of today's society, basically. And we're leading the way in our funky little experiments and so on that are probing the limits of what's possible to conceive and think about. And once those thought forms are implanted into this planet, which is what's happening now, then it'll grow from that seed. Those seeds are be like the seed formations of the nanoparticles or the GANs and so on. It grows from that seed, and you know, it's happening. It cannot be avoided. It's part of the process, and that's what we're here for, basically. And it may not be that we come up with the ultimate.
We have a purpose.
We may not come up with the ultimate. This may not be the ultimate energy device or the ultimate reactor for flight or whatever, but it may be the ultimate reactor to get to the next step of conceiving of what could be possible in this world of, you know, rotating mechanicality, physicality stuff that is beyond that physicality stuff, that incorporates, you know, reflects and is a reflection of the entire universe. This is a universe within the universe, and you know, that's the way Mr. Keshe approached his reactors too. He would be able to see, you know, star systems within his reactors and whatnot. So yeah, Mark, if you got something you want to show there, then sure, it's a good time.
I got more than enough to share. You know me, Rick.
Well, what is it that you have going on this week? Let's put it that way. Let's refine it
more
down a
than
little
enough.
bit.
Did you turn that I'm sorry, I was late to the party because I was trying to tidy up everything. You know how tidy.
Oh, that's why you asked about the globe here and so on. Yeah. We had this running earlier, but as I showed, it's got a bit of a flaw with. It's got a real wow to its rotation. Actually,
that's okay. My heart just, I'm wobbling. I'm feeling it.
It's got
a song motor. I know.
And it gets really extreme when it gets going. It's like a washing machine.
Just let her go, brother. Let her go. Hold on to it and just. I got something to show you about that motor and all that good stuff.
What I was showing was the bubble in the middle. I don't know if you can see it there right now, but
yes.
I'll just show it briefly again because we like to look at bubbles here.
I love the wobble.
The wobble could actually be important later. There we go. Okay, so you can see the bubble. There's actually 2 bubbles in there now.
Oh yes!
Let me get them moving there.
Oh, there it is. 2.
See, there they are. And now they'll bounce up against each other, but I bet I can't get them to combine unless I invert the apparatus.
Wait, that's like, isn't that like Mercury?
Well, they're positioning each other,
but they're actually repelling. That's pretty amazing.
Would that be like the
See, here, I'll get them to bounce up against each other.
But they won't go together.
They just bounce. They won't go together. They don't seem to.
Go slow. Try to make them touch each other.
You can do it.
Well, I have to do it by trying to jerk them over, basically. Now there's 3 or 4 bubbles.
Oh, yes. Hold them.
Okay, they just bounced off each other. One just went bang into the other one, and they still didn't. They didn't combine. There's 3 of them in there playing with each other now. It's so bizarre. You would think with all the agitation that those bubbles there, 2 of them just bashed in. One of them actually wrapped around the other bubble, and then it just pulled away again.
Yeah, every moment they're trying to position themselves. Every angle that you create, they're trying to find their best ways to show
but
them.
How is it they have such a membrane that they actually hold together? I think that's so incredible.
It's not at max. I mean, your sewing motor is at maximum.
No, not at all. It's just that when it gets going,
wobble.
The wobble gets worse, basically.
Oh, the cutting board.
Yeah, well, that actually makes the wobble worse in a way. Whoops, the belt just came off.
Sorry, yeah, they just need a fine tuning.
See how the bubble stays there even though this is stopped rotating?
Oh my goodness.
Oh, that's so sweet.
Yeah. And now it's finally made it up to the top of the sphere there. So
I love that.
It's going to be really cool to play with this, actually. I'm looking forward to getting it smoothed out. And I kind of like...
see what I got.
Go ahead.
Right on.
Please. Oh.
Okay, let's see what you got, Mark.
Oh my God!
Oh my goodness! Go ahead.
You're teasing us.
No, I'm not.
No, you're.
Wait. Oh, hold on there. I'm not teasing anybody. You know, I.
No, you always come through. Actually. You always come through with your stuff. It looks like your video is a little blurry there. I'm not sure if it's stuck on... it's good for close-up. Oh, there. It's cleared up nice there. Thank you.
Better?
Yep.
You know, when I come to the party, I come to play, right?
Yeah, you play hard.
So, this is where we were at, right? This is where we... kind of remember last week, right? Let's see.
Mm-hmm.
Last week, this is where I was last week.
Right, you're going to do some nano coating and stuff, or yeah, okay.
Or stuff, yes. And this is what was, I was going to have two. But I want to first say to, wait a minute. Well, you know what? I'm an old man. I want to show everybody. I make a list to be able to talk to everybody in the room that I know. Because I'm older than, when we talk about old, we talk about old. John, Lee, Sandor. Hi, Libby. Everybody. But first off, I want to say to Armin.
So you're not old at all.
Well, I'm 57 years old. Old enough to say I'm old now. People said, "Oh, is that the guy with the gray beard in the YouTube channel?" Yes, that's the guy with the gray beard in the old YouTube channel. So the old gray beard is gone now.
Yeah, you actually look much younger now, Mark. So it's interesting. I think the Gans is doing good for you.
Well, I was trying to put it on the beard, but it wasn't doing anything. So I said,
"No, don't do that."
Well, we try. You keep trying. Everything's in the working
Well, maybe
process,
you
right?
put it on the beard, but it was actually making your skin soft and beautiful underneath, just like the caterpillar,
So, I have to apologize, first off, to Armin, who's in the background. Sometimes when he speaks, he's like number two, and he's Mr. Kesh and our friends and everything, and I just can't. When he says stuff, I first take it as an offense to me because I didn't work hard enough to make him appreciate or understand what I'm doing. But this time, I had to go to. I was so upset last week with myself because I thought that I did something wrong. With the things that I was doing, but yet when it took me like 2 days to think about and watch our reactor group 2 days afterwards. That calmed me down, and then I thought to myself, doggone it, once again, I did this, and he taught me 6-8 months ago in April. And we got a lot of fun to go through anyway. So I want to just apologize. It's to Armin. This is whole dedication to Armin. My work this week, and I could actually cry right now because he works and thinks so hard, and he passes on his information to us for free. Free. Do you know what that? I say to people, do you want to learn about the Kesh technology? And they say to us, oh, how much is that going to cost me? Nothing. This is free, people. And do you want the authorities to come and talk to you? Well, you tell them, this is water and some metal and some salt. Do you want to yell at me for making water and salt and some metal to make people feel good? Well, then put me in jail or break down the doors and yell at my mom who feels great at 91 because I made some stuff to make her feel good. People, you don't have to worry about the authority anymore because that part is over.
We are the authority. We are the authority.
Well, we aren't. We're working very hard with or aren't. But anyway, I just want to say that Armin just really inspired me to do these things this week, and I worked absolutely as hard as I could possibly do. And I had to put the Christmas decorations up outside. So last week we talked about the coils, and he said to us, why are you going inside to outside, inside to outside? Let's have separation. And I went like, oh man, we made all these 3-coil magravs, and now he wanted us to separate it. And this was one of my first thoughts. And I'm just gonna leave it at that. This is one of my these things were our first thoughts in here. But by myself, on my own, I'm going to tell you how I came about these things 6 months ago when we had Revelation 6 months ago. And some of my other creations, I bought parts 6 or 8 months ago that we learned when we go to the thrift store. We don't know why we buy these things, but we hope that they're going to work. We're hoping, we show each other things, we do things. So let's move real fast now. I'm going to move really fast. So I hope, because this is a reactor group, and we theory is one thing, paper is one thing, and doing thing is another. I want to say hi to John, Lee, and Sandor. Eva, I hope you had a great birthday. Will, Alper, and Tony. Libby, here we go. Remember last week when I put this thing on that beautiful computer fan with all the GANTs around it? Armin told us to have we had all the electrons on the outside, but we needed a proton field. I might be saying this wrong, but he said to me, put something in the middle. And I can't remember. Did I have this thing working last week, Rick?
Did show it rotating at one point, I believe.
I did, didn't I? With the fan, I took it off and showed how I had the 7 points here, right?
Yep.
Okay, cool. Let's move faster. So then you said to us, hey, you showed us the CD player with the magnets, and it really rotated fast. And I thought, oh, that's great. I'm going to go get some CD motors and place them under my thing, my unit that's over there. And I'll show it in a minute. But these are the motors I got from the CD players. They're hyper motors. Those little fast, oh man. They burned out in like 5 minutes.
Yeah, well, they're not made to take the torque is the problem. They're
they were torqued up like no
one CD is what they handle normally at about 20,000 RPM.
So I had a few of them, so we had fun. So I just want people to remember or remind you. I did use, like my dad, some old fishing line. Okay, this is the old fishing line, 30-pound test fishing line that I use on this experiment down here that we're going to see. Okay, so let's just take the camera down here. And I just wanted to ask why I'm moving this stuff. I want to make a magnet. And, well, we'll get to that in a minute. Who cares about that? Shouldn't we talk and have a little fun? Hey, there's the old experiment that we asked about last week, right?
Ah, yes, the egg cooker in your kitchen.
It never moved, and I had the fan and everything underneath it last week, right?
Yeah, I think so.
Fan?
Yeah.
Okay, and then I went to the hyperspace with this one, hoping that I could get the balls and the eggs in the water and the GANTs to move, but that's a lot of work, and I don't know. So I burned all that stuff out, and we're from Detroit, so there we go. Here's the next one.
Oh my goodness. What have we got here?
Oh my God.
This guy never quits.
Everybody. How's that look?
Asmo, we're definitely going to have fun in space.
Are we ready to go? How's that look? How's it looking?
Looks good, yeah. Good clear picture. Perfect.
Okay, so last week we had the carousel of Ganses on the 30-pound test line. There's the lead. I should have my gloves on. These are all nano coated. I put them in caustic, but you know how we are. So there's the shouldn't touch it. There's the CH3, CuO, CO2, Bled and me. Bled and me.
What do you mean, and you?
And me. Nails, blood.
Oh, okay.
Amino acid. And you told me to make a center core.
Okay.
Okay. Everything inside now. Everything. All these and me and lead. Okay, you ready?
Whoa.
Just let it kind of balance out for a minute.
I'm hanging onto the couch.
Me too.
This is plexiglass, a quarter-inch plexiglass in front of it. I couldn't afford plexiglass on both sides. It's just drywall on the other side. And this here in the back part, I got to work on it. So this is, if it's going to hit the back wall, it's going to hit whatever in the back wall. I got a light on the top. This is just a single pole. You know, the motor itself is it's a sewing motor, and it's 110 volt at 1.1 volt or 1.1 amp. So what I bought was a 1.2 amp single pole dimmer switch from Home Depot or the big box store. Sorry, didn't mean to say that. I'm not advertising. So the dimmer switch will, well, it's enough to kind of control it. So here we go. I work my butt off. I don't know what's going to happen. This is the absolutely first time that I've turned this on for the full strength because I nano coated everything tonight. I bought this plexiglass because I was a little scared because it goes a whole lot faster than that. And then I thought if it breaks apart, it can hit the drywall and I don't care. Ready?
There's more? It goes more?
More? It just started.
Oh my God. Okay.
Oh my God.
Where
Don't
we
say
gonna
that,
land?
Rick.
Just tell me where we're gonna land.
Are we ready?
Yes.
Because it takes a little while for it to find a balance point.
Yeah.
Here we go.
Until you're not gonna tell me where we're gonna land, I'm not coming.
Need a road map.
Oh.
No road map on this one. You watch the road in front of your nose.
Okay, can you stop for a moment? Let's go back a little bit more to learn.
How far back?
So you were still increasing the RPM there? Is that the idea? We can't even hear. There's no audio coming through. It cut out the audio in your because of the probably the high RPM, the high frequencies are doing something to the audio.
Oh, sorry, Rick.
It's okay.
That's just the yeah.
Yeah, it's the automatic.
Going up in RPMs, and I downloaded a thing on my phone to figure out how many RPMs. I didn't buy a gun. I'm kind of a little bit poor when it comes to that. But what did you want me to do, Armin?
Can you stop for a moment?
Yes.
And let's go to the screen. And explain us what you're trying to do.
Oh, this is just for experimental fun.
Ah.
I'm not trying to do anything.
Everything is knowledge. I mean, everything is just like amazing. What you do is just amazing anyway. So
the purpose of it was just to see how many fields I could possibly. I mean, this is just all I could do for tonight. But if I put like a nano-coated plate in there, or a nano-coated plexiglass plate, plate with say gold and silver or whatever, whatever combinations I can put underneath the reactor is the fields that I want to move. Just like the balls that everybody's been taught to use. I just don't like the balls. They just scare the heck out of me. This is a 30-pound test line.
What do you mean it scares you? Why it's going to scare you? Balls are the best way to work with.
Well, I mean, are we supposed to find... I could probably glue a ball on the bottom of them. I'm a little bit more confident now when I see
you're doing all this work, does not mean you have to a little bit understand.
Okay.
What is, look, the ball is a containment. Okay, where you contain your plasma. What you put inside, it's like you put it in your stomach. The minute you put it, it's in a plasmatic condition because it's a gas.
Mm-hmm.
You put even the matter in there, it's still in a plasmatic condition. Because in your containment, the whole, what you hold it here, it's in plasma. Correct?
Yes.
Okay. So if you are creating a tube, and you put the GANs in here, you don't have a spherical condition.
Oh, okay. I see what you're saying. Yep. Yes.
Okay. You just have a tube over here which have contained plasma again.
Just like our Earth that has our what do they call it? Our equator. I don't have an equator. I don't have a.
It's not a point of
equator.
Just you have matter. Let's put it this way: you have doesn't matter. Doesn't matter. It's a tube, or it's a piece of wire, or it's a ball. When you nanocoat, now you create different condition. The matter. Even if you have a matter, and last workshop, if you understood what Mr. Kersh said, that you don't need even to nanocoat inside from the outside. Why? Because the minute you put the GANs inside, the inside condition, it's totally plasma. Doesn't matter even the matters.
Well, that's what I figured. I thought at least there would be some sort of in the rotation of all those ganses in that little tube that would throw out a field of those, and it would at least connect with the four that are above it, but it wouldn't be an equal field. It would be an above field, and I understand that. There's no equal parts on my working. from last week, you know, from the little fan that I had to this point, see you give us tidbits again. So the explanation is great. I love it. Thank you very much. So I know that this won't do very much, but at least we can watch it run out and roll and have a little fun, right? You can
having little fun, you know, if you understand properly, you will have fun different way. You understand? Start to understand a little bit, you know.
Well, come on. I mean, this is a week-to-week thing for me.
I understand, but you know, try to understand proper way. That is, you know, what you do, you don't have to torture yourself. You know,
so you know what? I never think of it as a torture.
I'm not just saying you are torturing yourself, just in a matter of a speech.
I'm actually enjoying the heck out of myself.
Okay. I will not say anything else.
No, you please. You know what?
I will ruin your enjoyment.
I dedicated this to you.
No, stop it.
This is just one half of it. And this is the moving part. The other part, you know, like some weeks that I, when I do my work, some weeks are when I have to work with the GANTs and my solutions and I have to balance, you know, the pH and all that. But other weeks I have to work with the engineering part, the physical part, the building part. Nobody else comes here and says to me, go to the store and buy this and buy that. You know, it's all me. So this week for me, arming was just absolutely in an engineering feat. I like I said, I had
okay, let's go back to your coils, please. Let's see what you've done in the coils.
Oh, well, I haven't even got to the halfway point on this baby to, you want me to shut her down? Watch this. That's the sewing motor. Wait a minute, Rick, one more time. Here we go.
Rattling sound. Just needs to be unified and it will work really superbly, and because of the construction is really neatly done and there has to be unified.
What's that, Alper?
It should just be
Can you hear me right now?
It's quite loud. I know it's
Can you
loud.
hear me?
Yes, sir. I can hear you.
Okay.
It's just that it's an amazing, and it should be added more, perhaps, to be experimented a little bit more, and just need to be. Well, what am I talking about? It's just unified. That's it. Like that vibration has to really go, and you know, see how it goes.
Okay, so sorry, it's a little loud here. I didn't mean to keep screaming over the thing.
No, that's okay. That's perfect.
Okay, so I'll shut this off. So if somebody else has something to show, just give me like 5 minutes and I can show you the next step. But
Armin was talking about getting back to your coils there. You wanted to see something on that. Is that possible?
So I'll show them what I got going for my next coils, but it's going to take me a few minutes to move everything.
Okay.
So, you know, it's getting late. I don't want to crush on everybody else's stuff. I'm sure there's somebody else that has something they want to show, right?
I don't know. Is there someone else that would like to show something in this few-minute interval here while we do a set change?
See, that's not even very hot.
Mm-hmm.
But I understand what he said about I could probably because I have an armature right here that I could work with, like Lee does with the fittings with the
PVC.
The PVC, yes. On the end of that, it would be probably a little bit more square, and then I could put a ball on the end of it, and you got to have the center point. So, but this was fun. I got the glass. I won't hurt myself.
Yeah, that's plexiglass, right? That's acrylic, I believe.
Acrylic 1/4 inch.
Yeah, that'll be fairly tough. Way better than glass, but it's not like polycarbonate. Polycarbonate is about 20 times tougher than that.
Yeah, but
it's also
20
about
times more cost.
It's about 2 or 3 times the cost. Yeah, that's
that
the
little
problem.
piece there was $150 if I wanted polycarbonate.
Oh, is that right, eh? Yeah, that's right.
So I got these 3 little pieces that were cut off the end that were 1/4 inch plexiglass or whatever they call it, and for like 5, 6, it was $12.
Yeah, right.
And then I got drywall on both sides.
Yep, that'll take it. No, it should be okay. Even if the acrylic was to shatter or break, it'll take the impact of anything that so it wouldn't fly into your face and so on. But it'll be fine for smaller things too. I don't think that those small things could break that plexiglass even if they hit it hard. But a larger thing would, and that's the thing about it. And when plexiglass breaks, it shatters in many sharp pieces as opposed to polycarbonate, which kind of bends and sort of warps and sometimes splits, but it doesn't shatter as such. So
we've been having conversation for a while now. That CH3 is just about ready to stop moving. Look at that little wiggler there. That's the last thing to move in everything. I swear.
Yeah, right. Eh?
It's the tough one. So, okay, give me 5 minutes. Give me 5 minutes. I'll push everything aside now. Somebody else wants to show. I'll get off here. And,
alrighty. Okay. Who would like to show something? Anybody out there with something they want to show? It's your big opportunity for your 5 minutes of fame. Just imagine. I've got a lot of shy people in this group. They were hiding their floating cars and powering small community power units.
Yeah, that's it. We don't want to get threatened here.
That's right. I'm all worried about getting threatened. Actually, it's one of my secrets is if you play with toys, then they never take you seriously. Think about it. It works. They come in here and see I'm playing with 4x4 trucks on their side. Hey, should be no problem.
Flash, Rick.
Pardon me?
Your setup is looking pretty flash there. Workbench and new scene looks great.
Yeah, I'm working on it every day. I try to haul more things away, and it's the same as the Kesh reactor. The secret is removing everything that doesn't belong in the space in the reactor. And that is so much true. And the more we get to the point of zero, the closer we are to the source, the closer we are to the fields rather than the physicality. And it's not possible to get to completely void zeroness in on this planet or even in space. So that's a given that that we can get close to that. We can get close to having a perfect vacuum, but never really able to have the full full Monty. You can never totally evacuate the a sphere like this, for example. It will always have some particles, some gases that will stick to the sides and all the little nooks and crannies and so on. Hey Mark, I'm going to mute you for now, and you can unmute when you're done there. It's just a little...
I'm sorry.
It sounds like Santa's little workshop in the background.
Yeah, that was, I don't want to harp on this again, but Keeley apparently had ways of pulling huge amounts of vacuum. He had some kind of wild vacuum chamber, if I remember rightly. We talked about.
Okay, well, that's...
Yeah.
Yeah, that's an interesting concept, how they created vacuum back in the old days. I'm not clear on some of those techniques. It might be interesting to investigate. One way you can create a vacuum that's relatively cheap and easy is what's called what is it called? It uses the vortex from a moving stream of water, actually. So you hook it up to your faucet. The pressure goes through this device, creates a vortex, and it's got an air fitting on it. The air gets pulled into the vortex, and it all dumps into your sink and goes down the drain, basically, or else you can fill a container. But it creates a vacuum on the line. It creates a really good vacuum, actually. And these devices are quite cheap, under $50 for a decent lab quality sort of device. But it does use a moving stream of water. You have to use your faucet on all the time that you're creating the vacuum.
We used to use a fitting that was a Y-type brass fitting that you would use as a you would have one end of a hose, water hose going into it, you're moving past a Y branch and then an output side, and on the other end of that Y branch, you could put that into a swimming pool and use it as a pump. It would suck all the water out of the swimming pool or something. It was
right.
Really cool way of a mechanical pump, with no moving parts. Just using that system of creating a vacuum. Mm-hmm. Yeah, it was pretty cool.
Yeah, very simple, basic, and yet it works quite efficiently. It's equivalent to hundreds or even thousands of dollars vacuum pump for real cheap. It's just you have to constantly run water or have a pump that pumps it at high pressure enough to create the vacuum, and it's limited in volume as well.
Yeah.
But great for small experiments if you want to evacuate a ping pong ball for some reason or whatever. Okay, what else? Any other questions or comments? Or anybody want to show something in a brief interlude here while we wait for Mark to rebuild his equipment? That's what I should be doing too. To do a takedown of this and...
I think we're waiting for you, Rick, balancing you on your ball there.
Yeah, I'd like to do that. Maybe I'll work on that in the meantime. Maybe I can actually get it done a little better and try to play with it a bit. And if there's
sure, it'd be fun to see it rotate a little faster.
Yeah, it would be. That's right. Maybe I need to get a weed whacker motor, put it on that.
Yeah.
That was good inspiration, actually.
Yeah, see, that could be the one idea that gets your trip going.
Yeah, right. Always looking for different motors that can work and different combinations that make it easy, because it's always a challenge between the motor and the shaft, the connection to the actual, like in this case, it'll be the connection to this little, this piece here, this rotating cap,
Yeah.
trying to get that straight and true. And see, it's
Yeah,
wobbling.
they call it indexing to mark it so that they drill it so it's exactly central. Yeah.
Yeah, well, I thought I had that figured out earlier today, but I guess I didn't. Maybe just the nut wasn't tight enough. What I did was I had trouble earlier because the washer I had only covers part of the cover, you know, like this. So, and the shaft and everything is not an exact fit, and the hole is not exactly in the center. So there's a variance on the shaft that it was just too sloppy. I thought I could tighten it down and adjust it, but then it got out of adjustment too easy. So what I did was I took a lid for a mason jar, actually, drilled a hole in it, and the lid actually fit in here quite exactly in the plastic cap. And that the metal hole, I could drill an exact 1/2-inch metal hole, and that centers the shaft, you know, with I thought. I even peened down the edges and made it fit perfect and everything. But somehow the vibration or all the whipping around seemed to have still made it not proper. So I'm thinking maybe I'm just going to crimp it down really good and try it again. And I do have a new shaft though that I'd like to put in too. So it's debatable. Maybe I'll put the new shaft in now, and that'll tighten down better than this old one did, which was never adequate. That is also going to change the relationship here. So many challenges. No, I'm going to put it together as is, and we'll see if we can get it to work just by tightening it down first. And if that doesn't work, I'll have to do a major shaft change, and that'll be a more involved situation. Let's see here.
You have a washer on each side, or?
Yeah, I did have, but I'm not sure if I've got enough shaft to be able to put the other washer in again. Because that was one of the issues here. I can't get the nut on the shaft because there's too many parts going on here. And that's hitting on one of the bolts here, so now I'm going to have to put a washer on over the head of one of the bolts in order to get it to actually work. So this is the way it goes. You think you're moving along good, and then just one step forward, 2 steps back, and eventually
you make it.
Eventually something starts working. It's so funny. I figure, oh, it should only take a couple hours to put these, drill these 3 holes I need to drill or whatever. But it can take, just simply drilling a hole can take a long time to set it up, get the right measurements, double check the measurements, triple check the measurements, drill the wrong hole, then drill the right hole, and so on. It's a challenge keeping up with
then you realise you need to make a complete modification. Yeah.
Yes. And that's all part of the game, I guess. Inventing things. You're always running into little roadblocks and problems along the way. But if you can make the equipment break down easily in terms of tear down, not breaking down reliability ways.
Yeah, it's just
So
like
much
fixing a
better.
car with
Yeah.
making your own parts.
Yeah, it's like
It's a couple.
sort of like
Sometimes
it's like fixing a Lada.
yeah.
I don't know if you've ever owned a Lada. I did. And
Oh, I owned a Lada once.
yeah, it's a lot of trouble.
Yes, it is. I gave it away.
Gave it away. And they took it?
Yeah, he did, and he was quite satisfied with it. I don't know
Yeah.
how and why, but he was.
I was very happy with my Lada. It was a lot of fun. Get it? And it was actually one of the most fun cars I've ever driven. And it had a great ride, handling. It was just really funky. It had a mind of its own and wanted to do things on its own, and you know, the electrical system only worked when it wanted to, not when I wanted it to. It was quite incredible, actually. You actually can have a symbiotic relationship with a vehicle like that ends up you take it personally, because it is so irrational that it's acting like a human instead of a rational machine that, you know, breaks down rationally or whatever. It's just, you know, usually when a part goes, it goes and it just stops working. But with a Lada, it'll often stop working and then all of a sudden start working. You know, one time my windshield wipers stopped working in the middle of the worst snowstorm, and I had to get out and fiddle with them and play with the wires, and I did everything I could on all the wiring adjustments and all the connections. I checked everything and wiggled stuff. Still, I couldn't get the wipers to work. So
just get in the car and try them again, and then they work.
No, in frustration, I shut the hood, slammed the hood down, the wipers started working. I went, yeah, right on, jumped in, the way I went.
Yeah, well, that's always another technique. Threaten or plead, you know, beg.
Or my favorite technique is the magic hammer, which is my large ball peen hammer, mechanics hammer that I've used for years. And I would often perform feats of magic and feats of magic and miracles with the magic hammer. I would be able to start vehicles quite often with the magic hammer. And it wasn't really the hammer, it's knowing where to use the hammer. And I think there was
starter motor on the GM motors.
Yes,
yeah,
that's right, on the solenoid of it, actually. And yeah, that kind of thing. So you learn that you can often start a new vehicle by tapping on the right spot underneath the vehicle. How could you do that, you ask, maybe? Well, it turns out that often the electric fuel pump, which is inside the fuel tank, could be just not, you know, it could have a loose brush or not making a connection properly. And if you tap on the tank in the right spot, you can often jog that enough to get the vehicle started and stop someone from being stuck in the side of the road and so on. And they look at me like, wow, how'd you do that? And it's a magic hammer.
Can we say something like, if you have the right intention, we can imprint on any devices, any tools, anything that we wish it to be work or align with us. Would that be ridiculous to say?
No, that's pretty much the shaman's rule number one. You know, you can imprint into objects, and the other side of that is you can also read objects. It's called psychometry, and you can psychometrize the object by, you know, say this is an ancient Egyptian vice grip, okay, and you know, I could hold it in my hand and tell what, you know, who was using this, or what it was used for, what the artist that made this object was putting into it, and what it was, what the conditions and environment around that object might be. And you might even get a vision, as someone that's psychic, when they psychometrize an object, might get a vision or flash or a scenario that they see of, you know, a past life kind of thing, where they are back at that time and using that object, or somehow they see the timeline of that object. So definitely that's part of what happens when, you know, we start using our latent abilities as humans, and get off the couch and get into the maybe get on the couch and relax into the psychic realms, rather than our busy life that we're so busy running around all the time that we're not able to relax into that psychic realm, because it takes a cessation of the busyness in order to get close to the that. It's a different brainwave structure, right?
I think a classic example of that is, you know, like when you see Olympic skiers on a downhill run, you know, they're visualizing the course before they take off, you know, in training and stuff like that.
Yes, and
that goes a long way to improve performance.
Same with race car drivers. They do the same thing. That's right.
Yeah. Yeah, and I think that proof is, it's measurable, that just before you do an action, there's a change. There's a detectable reading that they get just before you perform an action you're thinking of doing. Pretty amazing.
I often use that when I was fixing cars and bolts and stuff, because most of the time I didn't really know what to do. But when you just take it apart and think about it, and just let it tell you what it's going to.
That's right. That's right. Yeah. I use that same technique. In fact, I started my business back in 1982 or something like that, and it was called Mr. Fix-It's Traveling Workshop.
I love it. Awesome.
Okay.
Oh, and
I did mobile repairs. Okay. Well, that's part of what I do. So I put an ad in the paper. I was down in California at the time, actually, and I put an ad in the paper. Mr. Fix-It's Traveling Workshop. No job too large or small. I repair most anything. You know, all work guaranteed and so on. And basically, I made a decision then that I would refuse no work, no matter if I didn't know how to do it or did know how to do it. If I didn't know, I would find out how to do it and do the job. And that was part of my criteria. So I had so many jobs come in after the first couple of weeks, I had to take the ad out of the paper, and I just rode on that since, basically, from word of mouth and so on and so forth. And there's always a demand for a mobile mechanic or somebody that can fix things and so on. And I got all kinds of crazy jobs. You know, I got to fix this irrigation pump was the first job, and I had no idea what was wrong. I had to go in and figure out that the wiring was incorrect and so on. And it was a grand learning experience to put yourself in that position, to declare yourself an authority, basically, even though you might not know how to do the specifics of a particular job. But just because you know how to get information and how to work with your hands, and you have a good general knowledge, you know, already have some experience in the field and so on, then it's a matter of just doing it and not, you know, talking about it and thinking about it and so on, but just picking up the tools and doing it. And it can get you in some incredible messes, but you learn, and you can I never got in a mess that I didn't get myself out of in some way, and I always helped people and gave them a good deal along the way as well. I never, you know, ripped anybody off or gave anybody a bad bad end of the stick as far as that goes. And sometimes I paid for my learning experiences and didn't charge the customer and so on, because that's part of what you do as a, you know, a professional. You try to always upgrade what you're doing and learn more and more and so on. So I became, because I did that, it became broad spectrum, which is unusual in today's realms of mechanicking and so on, because normally you go to a shop and you specialize in one or two brands of vehicles, and you know, or you just do mufflers, or you just do brakes or whatever, and you don't get the broad spectrum, which I basically have rebuilt every part of most brands of cars, basically, and have worked on dozens of different makes of vehicles of all shapes and sizes, and right through from radio controlled cars up through to semi trucks. And I didn't refuse any work, even though it was, you know, taking apart an excavator to replace them, a big swing motor, a hydraulic motor in an excavator, for example. But because of that attitude and my willingness to do the stuff, I, you know, got the reputation of, you know, Mr. Fix-It, and that was my moniker for many years. And then once I branched off and started doing stuff on YouTube and became Mr. Fix-It Rick as my YouTube name, and started actually doing more experiments and so on to try to sort of wake people up and show them some cool things that they might have missed in their life. And
Way too cool.
thank you, Alper. And that's my Mr. Fix-It Rick YouTube channel, for those that might have missed that. And I do have some playlists there.
Crazy Rick, yeah.
Pardon me?
Otherwise known as Crazy Rick.
Crazy Mr. Fix-It Rick, yes.
Experiments, yeah.
Yeah, I did attain that sort of unfortunate name, but I learned to live with it and accept that as an okay part of, well, I eventually, and what many people here have to come to a sort of a realization when you're involved with the Keshe technology is, in a way, you become not famous, but more out there. You put yourself out there. You're exposed to more people than you would be in your narrow circle of friends, for example. You know, as Mark mentioned earlier, his family all thinks he's crazy, you know, and so then your friends and family become broader in terms of, he's got a following of people from, you know, that are following him, I'm sure, that love the stuff that he's doing, and he puts out a new video and he has people sharing it, and, you know, word gets out, oh, look what Mark's doing and so on. And so he's had to put himself out there and become more extroverted in a way. I was talking about this earlier, that it turns out, most inventors are introverted, and it even turns out that most people are introverted. I read statistics a couple of days ago that 60% of people are introverted. I thought, whoa, that's a pretty high statistic. I thought it would be more like 6% than 60. But it just goes to show that, and it's becoming more prevalent. You'd think that with all the networking that we're doing, there'd be less introverts, but there's actually more now than previous. So it's interesting that even with this introverted way that we like to be, we like to not, be bothered by people that are weird or upset us or all that kind of thing. But if you get involved with YouTube, you get involved with Facebook and so on, you're going to run into people that don't like what you're doing, or just have a nasty streak and don't like what anybody's doing because they don't like themselves. They don't like the world. They have a grudge against this, a grudge against that, and they're quite willing to tell people on those various networks all about what they think the world's about and so on. And after a while, though, you learn to tolerate that. It's just another troll, ban and delete, or if you must, sometimes you can rationalize with people. I've seen people turn around 180 degrees and stop their saucy kind of critical attitude and just suddenly go, oh, thank you for that piece of information. I never looked at it that way before, and gee, I think I'm going to, look into that and so on. And that can happen, and that's part of what's happening around the world now. There's so much interaction with people that we're starting to look at other people's points of view and so on, in spite of the division that apparently is being seen now in various places like the U.S. and whatnot. But I think we're going to see that all come around again. All this separateness and division that's been apparently created might just come around and show as a new form of recreation of those forces in the next short while. Either that or it's all going to blow up. So either way, we keep our fingers crossed and we just go forward with a positive and hopefully playful intention. And that goes along with what is the natural attitude and aptitude of the essential self, of the true parts of ourself that may endure what might be called a passing or death. And I think that gets sort of forgotten sometimes, and we focus on the physicality stuff and our own physicality and physicality of things and our reactors, and get too involved with all the bearings and gears of things rather than the essential force that can be examined when we work with this equipment. Then I think we're focusing on the wrong thing. If I was totally focused on how much money I was going to save in power, for example, and I was totally driven to make magravs that save in power, then that's maybe a good thing in a way, and that it might advance the technology and so on. But maybe it's the wrong attitude to have when working with this technology. Maybe it needs to be more inclusive, more what's the word for it? Or maybe more is the wrong word. Maybe to use the less is better. There's a phrase, less is better, and maybe that's the case. So we're like a ship when we're getting rid of the overburden and you know, in a hot air balloon, and you start to lose your buoyancy and start to go down, then you get rid of the ballast, as it's called. So your sandbags and eventually luggage and clothes and, you know, shoes, whatever is left goes over in order to maintain your buoyancy and your levity and to keep moving along. So it's kind of like that, perhaps, is less is better. And if I talk less, then that'd probably be better too. So let's move along here. I'm still trying to get this lined up. It's a lot better than it was. It's still way...
Sometimes it's as much about the journey as anything else.
Yes, that's right. Yeah, and that's a big lesson I've discovered working with these Kesh reactors is, you know, you're never really done or complete or finished. It's always just another step in the game to learn something, and it's all in the learning and doing, not really in the end result as such. And that's, I think, true of people sort of are learning that perhaps in this technology. But on the other hand, we have to see results because we're human, and it's only human to have results and expect some kind of results, and you know, have things happen in the universe in some sort of way that we can explain and rationalize and have fun with. Okay, maybe that'll work better. This is hard to tighten up. It's a little, everything's slipping underneath. That's why I have the new shaft, which is not in play yet. Okay, well, it's definitely a lot better. I'm not sure if it's going to stay in that position. I think what I will do is use a smaller sphere for this little test. Okay, it should be enough in this to have enough enough of a bubble in it for a test. This is not down good enough. Yeah. See, it's bouncing up. I gotta squirt a little bit of fluid out, I believe. Just bear with me a second here while I... Well, I got a big bubble I didn't want. Well, we're gonna go with the big bubble I didn't want anyway. Bubbles are good, right? We like bubbles.
Yes, we do.
See, we're crazy. My affliction is now being passed on.
Yeah, well, bubbles can be round, and in the plasma world, bubbles or round is good. Or spheric.
Alrighty. So.
And it could even be magic bubbles.
Magic bubbles. I think so. I think so. And if depending what's in those bubbles, if it was, for example, exotic form of hydrogen, maybe with a bit of helium, maybe with a bit of argon, then you got all the constituents of the first Kesh reactors right in the middle.
Yeah, well, there's water
of a controlled environment. Pardon me?
Hydrogen.
Well, it's an interesting point. I mean, yeah, it's 2 parts hydrogen, 1 part oxygen. It's basically oxidized hydrogen. Water is oxidized hydrogen, or dihydrogen oxide, you could say. Have a glass of dihydrogen oxide, please. So there's lots of hydrogen in there as far as that goes. And not only that, we have to take into account the important idea of the self-ionization of water. If you look it up, Wikipedia, self-ionization of water, it's a fascinating idea, fascinating topic. You take a sphere of water, and any of this water, any ocean water, any water anywhere has a self-ionizing ability. It's able to, all of a sudden, normally you've seen the picture of hydrogen and oxygen. They're connected in sort of a V-shaped molecule, right? The hydrogen, oxygen in the middle, and 2 hydrogens. And I think it's 107.9 degrees, or is it 109.7 degrees? In any case, it's, normally like that. So, and it's a pretty strong bond in water, and we know it, forms sort of crystal structures and whatnot, and so on. But what's important is the self-ionization of water is approximately every 10 hours, each water molecule will spontaneously break its bond, and you'll have a hydrogen and the OH, essentially. There's some transition molecules in between, but essentially you have a hydrogen and an OH. It breaks the bond, but it snaps back together, back into the H2O within a few picoseconds. It's the fastest reaction of all the chemistry, apparently. And so I think it's fascinating to know that water spontaneously has this hydrogen and basically a proton sitting there through this fission of the separation into the atoms of the molecule. Happens spontaneously every 10 hours just because of the fields, because there's always fields on the micro level, on the atomic level. There's interaction of fields, and sometimes these fields all add to each other to provide a peak, and that peak in the liquid has enough energy to break that bond of the hydrogen and the OH. We think the energy levels, there's no way there's enough energy level in there. Well, it's on that beyond the nano level, even to the atomic level. There's lots of energies going on, and sometimes, like I say, they mate together to give a peak, and that splits enables this self-ionization of water. So we have the hydrogen in there. And I'm thinking, if you were spinning this globe, would not that self-ionization still be taking place? It would not, in that picosecond when that hydrogen is released, if it was close to the center, maybe there's a chance it would just become the gas in the center rather than reuniting and becoming that H2O molecule again. So
kind of the idea behind spinning the ball at a certain RPM at 24 hours a day.
And for a long period of time, exactly. And what did Mr. Keshe do in order to go to 129 Tesla? They were running the reactors for a long periods of time, and different combinations of reactors and lots of reactors, and with Armin's setup, the spaceship configuration and so on. It didn't happen instantly. It didn't happen just because you got that geometric configuration and that RPM. It doesn't happen. You would think it would. I mean, what can happen in a empty reactor with some gases in it or some GANs or whatever. I mean, it should achieve a steady state within a minute or two, you would think, and maybe some temperature differences. But no, there's actually a lot going on with any spinning globe or any spinning anything. It emits fields. There's gravity fields going on. There's electromagnetic and other types of fields as well. There's a heat signature. There's the vibrations and the harmonics inside, creating peaks and valleys of pressure and the plasma fields of everything are interacting and mixing, whereas normally they might stay separated in their own entityness and whatnot. So, oh boy, I'm going on here, and probably Mark's been ready for a half hour or something here. Well, let me just fire this up, see if it's any better than it was before, which was the purpose of all this some time ago. Well, it wobbles, but the bass is better, so let's give it a go. See here. You can see the bubbles are just at this top. I don't know if you can see that. Let me bring it in closer here.
Give her more power, Captain.
Yeah, definitely. Definitely. Let's have a look at that and let's see what the, oh, there, that's better right there. Got some, I think the overhead light's the worst, yeah. Okay, let me just get rid of that. And that'll help the situation enormously. We don't have enough light on the subject. It's getting there now. That's pretty good. Alright, I think I'm pretty happy with that. It's a little funky, but you can see the bubbles going around there, and we're not at a very fast speed. We're at about 60 RPM or something like that. Let's take her up and see what happens. You see the bubbles moving down the sphere as I rev it up. They sort of stick to the sides a bit as it rotates around. Probably doing close to 200 RPM now. And now it's starting to form more of a vortex. The bubbles are pulled away from the sides of the sphere, and they're in the center now. But it's bouncing them around so much that they're all kind of jiggled up. Let's go faster. Yep.
It weebles, it wobbles, but it don't fall down. That's the good part.
Yeah, it's still a long ways from
there's that column forming.
Try to hold it down here so it's not vibrating so much.
Well, there's definitely that column vortex.
Yeah. That's what happens when you have a lot of bubbles in there. They, instead of bouncing off each other, they are forced to form that column, basically, yeah. And the more you spin it, the more it becomes like a regular column. Whoops, except when you do that. It's interesting to see the reaction. There's a precession that goes on in the vortex. Like, even just a little movement, you see how it changes the, you can actually see the wave. little faster.
Hey Rick, you've replicated the motion in the ocean.
The motion of the ocean in a jar.
Looks like it's leaking.
Leaking?
Yes.
Don't think so.
You see it on the between the ball and the base. You know, thing on the. Yes.
Oh yeah, there's a tiny bit there. Yeah.
What is that?
It's got a bit of a leak. Yeah, it's not spraying out though. Really, I think it might have been there from before even. Okay, I'm gonna take it up a bit more. Not doing its self-balancing thing, that's for sure.
Looks pretty cool.
It's split up into separate bubbles there now. Interesting. See, this is what I noticed is the difference between my little truck and this is the bearings and this box and everything are mounted pretty solidly, and the ball shakes all this stuff. When I hold it, that means the ball has to shake more to compensate instead of this stuff shaking. So with the truck, it's a different situation. The truck, the suspension takes up all the bouncing and so on, and the ball tends to run more true that way. But with this guy, since it's solidly mounted, everything else wants to shake, and the more it shakes, the better. The more the ball is allowed to be rotating around its core, which it likes to be rotating around. Try it up this way a little bit, see what that looks like. Boy, it definitely jiggles those you can almost form as the bubbles and play with them with the RPM, which is what I hope to do with less bubbles in there. I have to reset it though to get less bubbles. Well, it takes a bit more refinement of the apparatus, let's say, but it's a good first attempt, and let me try it while it's level and let's see if it's still out of balance. Yeah, it's gone way out of balance here.
Well, it might even create its own bubbles if you completely evacuate it.
Well, that's what I'm thinking, is at a certain RPM, probably a very high RPM, maybe beyond the capabilities of the materials, that like in the center, you've got quite a let me see, the lighting's not good there. In the center of the ball, you've got enormous forces that are essentially creating a vacuum in the center, and all the high pressures at the edges of the sphere. So it wants to create a vapor bubble, at least in the center. And what it will do is it'll pull out all the air out of the water, because all water has air in it, unless it's degassed, and it takes quite a bit to degas the water. You have to put it under a vacuum or else boil it for 15 minutes to get the gases out. And so what we have is oxygen and nitrogen dissolved as air right inside the water. And when it's rotating, And you can actually see it when it's rotating. There'll be a little wisp of vortex in the center besides the big bubble, and that'll be the air coming out. It'll start drawing it out and pulling it toward the center of the sphere. So any stray air that's mixed in with the water gets pulled into the center and starts feeding that big bubble in the top there, and it ends up creating more of a bubble. It's the same as if you let it sit for a period of time, the bubble gets bigger as well. Oops, I just lost my internet again here. Oh. Okay.
We lost Rick for a moment there.
Hello, can you hear me?
We have you.
Okay. Yeah, I lost the Zoom again. Did I say a bad word? Let me think. I don't think I said anything bad. I wasn't talking about any agencies.
It could be a bandwidth issue.
Yeah, well, the cable company likes to play with their equipment late at night like this, and they think no one's paying attention for some reason. I guess most businesses don't operate at this time of day. I don't know. In any case, I was talking about the bubble and how the rotation causes the air to be drawn out of the fluid, because basically it's under pressure and under vacuum, and the light stuff will go to the center. The gases will go to the center, and they get pulled right out of the high G force of the water, and the gases go toward the center. So whatever was dissolved, whatever imprint that those gases have, they end up with that being pulled into the center, which is an interesting idea in itself. As Mr. Keshe says, each oxygen, each nitrogen atom has its own idiosyncrasy and its own signature, and it can be in different levels. Each are on different energy levels, more so than what science is telling us, and more so than even just the isotopes. So in any case, this oxygen and nitrogen gets pulled out of the water, and like I said, you can actually see little bubbles being pulled out, and it's like a trail in the vortex when it's vertical like this. I don't think you can see it right now. This is probably not a good example, but the lighting has to be just right. Sometimes you have to use a laser to see it and whatnot. And it helps if there's fresh water that needs to have all the air taken out, which just isn't. I don't see it there right now. But under the right conditions, you might be able to see a little trail of air bubbles in the very center. And it's like a micro vortex, and it's like a thread basically that goes from right in the middle and the bottom right to the top. And so the idea is that once that goes out, then what's left? What kind of voidness will be in there at high speed? Well, it has to be either just the water vapor itself, or a voidness of a vacuum, essentially with no other, if the gases are pulled out, which is good because under sonoluminescence, when you got that bulb expanding and contracting and giving off light, then it actually takes several hundred cycles before it starts to light up. And the reasoning behind that is it has to expand and contract, and basically to get rid of, again, this concept of getting rid of, to get rid of the oxygen and nitrogen in that little bubble. And that actually gets, the nitrogen and oxygen get used up through a chemical process that occurs in that expansion contraction, and it ends up being dissolved back into the water, leaving mostly the argon left, which is 1% of our atmosphere. So the argon is very much alive in terms of plasma. It's very easy to make an argon plasma. And so it ends up this little bubble, micro bubble that's collapsing and expanding, eats up the oxygen and the nitrogen. They get kicked out, leaving a much higher percentage of argon, and the argon is much easily ionized, and there's no other particles to get in the way of that little micro reaction going on. And that's why you can get suddenly a flash of light and a burst of energy given off by this tiny wee little bubble. So anyway, I think I went on a bit too much there, and we have to get back to Mark and Mark's stuff. You ready, Mark? Are you there? Is anybody there?
Oh, yeah.
Okay. Well, fire up what you got there. We're going to have to break things fairly soon here. I'm speaking of breaking.
Getting late, I know.
Yep. But always welcome your stuff. Okay, there we go. I'll get it spotlighted. And
just a little fun here, you know, because this is step number 2. How's it look? Is it good?
Yep, looking good. Yep, beautiful.
So a couple of things anyway. So let me just turn this for a second. These I made, you know, like this is, remember the space arms that I had on this thing before?
Yeah.
Well, last week I was so, Armin just blew my mind when he told me, or came in and, you know, said the single coil and a single wrapped. So you had 4 wires for each one. You know, 2 on this one, 2 on that one. Do you remember that?
Yes. Mm-hmm.
Okay. So I made these in April, and they are exactly that. They're single coils. One coil, or just one single wire that goes through the piece of vinyl.
Somebody's got a lot of mic noise that's
Oh,
sorry, Mark.
Sorry, that's probably me here. So let me stop when I was adjusting my apparatus here. Sorry. Okay, go ahead, Mark.
Well, anyway, so the coils here are just a single wire that goes wrapped through themselves with a vinyl piece of tubing that separates each other. And that's another lesson all in itself. But I just wanted to just show the progress that now I know that these were my concept was right when back in April of this year when we want to keep separate fields. So if you just look at the representation of this, each arm, each layer, or each shelving is gravitational and magnetical. There's small with large, large with small, small or large with, wait a minute. Anyway, I'm all mixed up, but it all works, you know, in conjunction. Each layer feeds each layer, and now I understand that each motor or each mini maggrav feeds each arm. So I have a mini maggrav under each arm, under each one, 4 points, 4 arms, 4 layers, magnetical and gravitational. But what I was missing was, and I did this unconsciously, I didn't understand why I did it back in April, because I made these back in April, was to put a central or a hole in the middle here. And what I have in the middle here is now, which Armin said, from our neutron, electrons, and protons, we need a central central point where we can have all of our ganses in the middle. That's the middle of the central point. So what I did is, I don't know if you can you see it? I'll bring the camera a little closer if I have to, just for the explanation.
Yeah, but we see you, Mark.
So what I've done here is, in the middle of the cores, these are all single cores that can be filled with GANs. Small cores can be filled with small GANs, or lighter GANs. Heavier GANs in the in the bigger cores down here, and they're all vinyl tubes. And I have a single. Each one of these are just one wire going in, one wire coming out. The only reason why we have caps on them is so that we can inject GaNs material in each and every one of them. So if I need CH3 here, CuO here, maybe a little, but whatever, it's interchangeable. But the revelation is that I needed a center core for all this, and I didn't know how to get a piece of vinyl tube in the middle here, suspended in the middle. And I don't know if you can see that, but what I've done is I'll nano coat this vinyl tubing that's 3/4 inch vinyl tubing that goes from top to bottom, and there'll be a nano coated piece of wire that comes out from the top to the bottom, but we'll get to that later. But at least I have a center core now that's being held for 4 points with the rubber bands that's completely suspended in animation. I didn't think I could do it, but I did. How do you like that?
That's brilliant, Mark. I love it. Yep.
So that looks awesome.
It's completely in the middle, suspended with the rubber bands from side to side, so that I can have GaNs of everything that we, because the other ones we know that go inside the V2s, I have those all. But anyway, Armin told me we needed that middle, and I kept thinking, how am I, I made these plates in April without even thinking about it. I cut the, like an 1 3/4 inch hole in the middle without even thinking about it. I just thought, this should be a hollow core. Why? I don't know. I just did, but I did. So now it makes sense to me. So now I have a tube that I can actually put GaNs in the middle of it, and actually with my my middle mini maggrav here, which I'm going to connect to the tube here, and I'll show you how I'm going to do that later. But now I know that the rotating core can be connected here, and I made a little boo-boo tonight. This shouldn't be in an upward position. This should be in a downward position with the center core of my mini magravs sticking down. But I worked so hard tonight, I made a mistake. But anyway, this should be a reverse. This should be downward with a center point that connects to the middle here, and the center point connects here, so that when you see the rotating points that are going to go into the middle, that'll feed that. And each one of these, now I realize, will be a feeder. These will be rotators that'll feed this. And it took me a long time to figure out how to get all the energy from these little mini magravs that are completely by themselves into these units that are the outbound units
that feed these units that are the inbound units, that this is where the connection is. And if I need to, if you wanted to connect to electricity or not, this is where the magic starts. But so at this point, does anybody have any questions?
I don't have a question, but I had a comment when we had the pulled back view. I was thinking, man, Mark's got his spaceship sitting on a pyramid over there.
Yeah, I was going to suggest is where's the shell? where's the skin, basically, because all you need is a saucer shape. But of course, you can't build that in your garage, because then you'd have to dismantle your garage in order to get it out. People, that's what we have to be careful of. That's our luck.
It up faster, he'll just phase right out of the garage.
Yeah, maybe we can just pass through the walls, but
that'll be matter through matter.
That'll be the ultimate disappointment for us Kesh fans, is someone finally invents the perfect saucer, but they can't get it out of their basement because it's too big.
No, not really, because when I built this is all disconnected at the joint right here. These are all the nylon screws that are, 3/4 inch screws that are here. So when the base comes off, then I only have the center core that we walk out with. And I can situation this anywhere I want. Yeah,
it looks grand though, that's for sure, and it looks like it is the core of a spaceship. It's got that look about it. That's still a little funky in terms of, I'm not sure if I'd go to space with it quite yet, but it
might be a little bit rickety, but like
rickety, that's the word, rickety. Oh, I see where the word came from.
Right.
My contraptions are often rickety.
Rickety. The same way with the little pyramid down below here. We find the center, do I add that here? Do I add the ball underneath it? I have geometrically, if I looked at everything, they would probably symmetrically form underneath each other. And I didn't even design it that way. But that's not here nor say. This is where we're at right now. We're working and it's late and anything. So a lot of people want to see it move, right?
Yeah, sure. We like to see things spin here. This is so grand.
Now, if you notice that 5 will start, 1 won't. It's tired, or it just like says to me, we're at 6 amps. This number 2 just waits and waits and waits and waits, and it'll wait until it feels like waiting. And I've done this several times, and it won't do anything until it feels like doing something. But anyway, you can kind of get the idea.
That's great. Boy, it kicked in good. It wasn't like it wasn't hesitant or anything. It just boom, kicked right in. Oh, now it's my turn to dance.
Well, that's kind of the way it is with anything, I guess. And it's, So
even in the space shuttle, you had the solid rocket boosters that were waiting for all the other engines to be fired off first.
Right.
So anyway, so now that I got an idea of how this is supposed to work,
You have that loaded with GANs, Mark?
Pardon me?
Do you have that loaded with GANs yet? Because that thing looked like it was about to take off.
I just got these nano coated tonight. I mean, everybody knows I broke it down 2 weeks ago, and I've been working on the nano coating, and Armin made me shift from the little units behind me back here to this that I had. I had to shift all my thinking because he said single cores were better than copper coil, double coils. So my math, the way I have to think about how to connect it, went from that stuff over there this week to this stuff over here, and I still had that, little sewing machine motor on my mind too. So I had a few things I was thinking about this week.
It's looking great.
So on this front, I haven't had time to, as you can see, I haven't had time to nano coat because I had a 3-core unit. Now we've went from 3-core to an 8-core unit with 6. I don't know if you can hear me or not.
Yep, we can hear you.
I am digging the weird, creepy sci-fi sound effects, though.
So, this mini MagRav has 7 coils on it. Feeders and mini coils. Oh, I burned that one out. But anyway, I kind of put it together kind of fast tonight, but I understand the feeding point, and if I thought that these mini MagRavs should have been able to feed by themselves, but now I know that they're going to be able to. I'm going to make a thing that connects them, if you know what I mean. If I can make a coil that comes off of here with a double Y that comes here and sits on the top of the middle of the lead, the middle one, because I have everything moving to the middle, lead in the middle. Now, if I could just, I thought to myself, well, how in the world could I get all this stuff to move to these point, these outbound, which feed to the inbound? These they'll be more useful if I can create the fields that go up into it. So now, knowing that it's a position point, this middle one here, all I have to do is straighten out that middle one and make a coil that comes down from here that connects there. And this is the question I have tonight for everybody. Where's my paper? I want to make a magnet. And if I made a magnet, a GaNs magnet, it would be copper, cobalt, sulfur, nickel, iron, aluminum, titanium. I have all the ingredients except for cobalt, because if I had GaNs of all those ingredients, I could make a coil that had all those GaNs on that coil, which is a magnetical coil with those ingredients. If you looked it up on Wikipedia, it would tell you the smelters dropped all those metals in the smelting, and then all they did was electrify that metal to make a magnet. So we already know that plasma makes an electrical field, and so all we have to do is have those ingredients of metals together and make a GaNs of it, and then I can make a coil dipped in that GaNs and put it over these, and then actually now this is the magnet starts from here, and then as I turn it up, a rotating field around a magnetical coil now sends and then it's a single field. And then we go from there. Does that make sense? Anybody?
Sounds logical, but I think you've got everything connected via plasma fields anyway within that space, regardless whether it's over the top of the MagRav or to the left. It's all connected by the plasma field already.
Maybe. But we always have to have double, like any kind of science you want, or any kind of system you want, double or triple the system. You want to make sure you have a backup. And that's why I thought you had the, at least if I had those metals in a GaN state so that I could collect those fields and then start moving it in a plasmatic field, well, maybe we might be one step ahead. Maybe. What do you think? Anybody think? Do I think too much, Rick?
I think you do a lot of hard work in preparing your contraptions here, and between you and Lee, I'm amazed at all the work that you put into these things and the thought that goes into them, and the the appreciation of some of the basics of the Keshe teaching and so on. It's great. I love it. I don't know what it's going to do or whatever, but it's already done a lot in terms of inspiring others, and it's just to see something like this it's almost like watching some sort of being come into being born or being created. So it's a fun process. Enjoy your interpretation.
I was thinking of saying it's alive, like the old Frankenstein movies. But I mean, it's awesome.
Yeah, it did have more. It did look like it had arms before, when it had like two arms coming off, and you had the rotating things on those two arms there. It was like a little robot. It's more contained now. It's more centralized. Its chakras are starting to line up, actually. Now they're much closer to the center and so on.
Well, I think you can kind of understand how each of them have a purpose. It won't be about another couple of weeks before you'll be able to see how I connect each arm to each plate. Because if you look at it, which I try to think about, each arm and each plate is actually a small ring and a big ring. A big ring and a small ring. A small ring and a big ring. So once I start wiring it together, that'll still give me my infinity loop. And then once these are all connected together, which would give the arms the energy. That's what I'm thinking. And then with the two tops, that I'm thinking I can make a coil, that a nano-coated coil that can stick up into both of the plasmas, both nano-coated copper wires that stick down here, and then have a small Armin coil. That's my idea, is to have a small Armin coil, maybe 2 millimeters long, where the center piece goes into the Armin coil and spins around it.
Right. Yeah, I was going to suggest an Armin coil could work good there.
That's all I use is Armin coil.
Mm-hmm. Right. Yeah.
And I just ordered these machined 1/16 rod, 18 inches long by 1/16. Because when you try to make an Armin coil, to make anything like that, it's really hard. So it's a machine. So,
right. Yep.
So now I can put it in my what I use to make my coils.
Mm-hmm.
I have it, you know, what am I? Anyway, so yeah, I ordered those so that I can make the coils, so I can make the dinner, whatever.
Yep.
And away we go.
Yep, right on.
So anyway, it's getting late, and we'll just feel the fields, and I want to send out a lot of love and let a lot of people know that don't be scared. You know, be creative. Use your right mind instead of your left mind, because if anything at night you want to dream to go to the right, not to the left. You don't want to be to the left. You want to keep to the right, and you'll be very happy because we're very creative. We're not using the right part of our brain, and a lot of people will tell you that the creative part is in the right part of our brain, and just keep creating and don't be scared. You know, we might end up here, there, or the other, but we'll all end up together.
That's great, Mark.
Thank you, Mark. Look at that thing do the boogie woogie.
It sounds like it's about to take off.
It does. It's got the right sound and the pretty good look too. And those legs stop shaking when it gets up the higher speeds, and it gets more solid looking. And
I have a feeling he puts his hands in it and flies away.
I've worked as hard as I could tonight, sir.
Viva Las Vegas!
Great fun. Thank you, Mark. Okay, well, we should probably sign off for today's fun and festivities. It's been 4 hours plus here, so we've investigated several avenues and opened up several avenues for next week's activities as well. So this is all good. Any last thoughts, comments before we wrap it up here?
Thanks, guys. It's good to see you all.
Dr. Keith, you had your mic open there. Is there something you'd like to say or show?
Oh, I just was wishing everybody a great week. It's been nice to finally participate, at least with my voice.
Right on. Do you have something that you want to present maybe next week or something? Or
I have some nano-coated coils, but that's about it. I mean, nothing special yet.
Okay.
I've only been in this for about 6 months, and I'm finally getting nano-coating on my coils. So,
well, I appreciate your comments in the forum. Thanks for the support and so on there, and it's good to see your comments, and other people are liking it too. So I hope you keep with the Kesh technology, and in spite of when I look at this picture and I think, I just look at it now, it's a pretty funky, and this is the way we are. Oh, sorry, I didn't mean to insult you by calling you funky, but you're funky. It's funky is cool, and it's this assortment of parts and coils and stuff, but yet there's a lot of thought and a lot of feeling has gone on behind this, and it kind of represents the whole Kesh Foundation in a way. It's sort of patched together with all these people from around the whole world and all these different languages, and it's all pieced together. It's scattered all over the internet. It's hard for people to find information. There's so much information all over the place. It's like this machine. There's a lot of information there in what we're looking at, and it's funky and so on, but yet somehow it works. Somehow it produces, I guess the ultimate is it produces an effect in us, as if a similar effect that perhaps good art would do, or good music, what we call good. Good being the root of the word good is good, which is God. actually. So it's something a little closer to God than what we'd find normally on the street, let's say. So that's, I think, important. We're getting closer to source. We're bringing up that jubilant source energy, basically, that makes life worth living. So,
and it's always been within us already, so
that's
we
right.
just go with it.
Yeah, and most
if it wasn't for the mad scientists working in our basements and garages and living rooms and wherever else, you know, half the inventions in the world never would have happened. So just keep on going and just have faith and trust in yourself, because we already have the knowledge within us. We just have to ask the right questions to get to it.
Yep, that's right. Okay. That's a good note maybe to end things here. And
good works, good thanks, good love to everybody.
Cheers,
right
Mark.
Good deal.
Thank you.
All right, thanks to all tonight. And I'm going to end the live stream now and call it an evening for the Keshe Plasma Reactor Group for what is now Wednesday, December 7th, 2016. All right, see you all next week, I hope, and bring your inventions and let's have a look at them and have some fun. All right, bye for now.